These are the topics I am going to cover as part of Introduction to Terraform. What is infrastructure as a code? So infrastructure as a code, which means if you are creating your infrastructure with the help of scripts or any files or using any tools, these kind of techniques will be considered as an infrastructure as a code. For example, if you are having a shell scripting where you have sequence of commands to create an EC2 on AWS cloud, then that will be considered as a infrastructure as a code. So the point is, when we say infrastructure as a code, that will help us to automate the entire infrastructure provisioning by using codes, scripts, or any tools instead of creating the infrastructure manually. So that the infrastructure as a code will be like a blueprint for the particular infrastructure or the resources. So with the help of this infrastructure as a code, we can provision, manage, or even we can destroy our entire infrastructure using this infrastructure as a code. So it enables our organization to completely develop, deploy, scale out our cloud applications with greater speed, less risk, and reduced cost. So this is why we use infrastructure as a code. We have many tools available in the market for achieving this infrastructure as a code concept. Terraform, AWS Cloud Formation, Azure Resource Manager, Google Cloud Deployment Manager, Ansible, Chef, Puppet, SaltStack, even Vagrant, because these tools will also help us to create the entire infrastructure automatically. Let's talk about what is Terraform. So Terraform is also an IAC tool, that is infrastructure as a code tool, and it is created by HashiCorp, through which users can define the resources, what need to be created, what need to be deleted, or what need to be modified, and they can use modules and they can provision the entire data center infrastructure easily in a secure way and efficiently using a declarative configuration language that is known as HCL. In another way, we can call it as HashiCorp configuration language, that is HCL, or even Terraform supports JSON format as well. But we predominantly use HCL format. That will be easy for us to create these resources. It is not only to create new infrastructure, even we can manage our existing infrastructure as well. For that, we need to import all these resources. Okay, why should we use Terraforms and what are the benefits we have? The first point is infrastructure as a code. Yes, we can manage our entire infrastructure through code, that making our task easier to create, update, and destroy it. Even after 1 year or even after 2 years, also we can use the same code to update our existing infrastructure. So this infrastructure as a code will be a blueprint for our entire infrastructure. Consistency. Terraform ensure the same configuration defined in the Terraform files are applied across multiple environments like development, staging, and productions. So if you create a one environment using this IAC, then we can replicate the same for multiple environments in matter of seconds. Then automations. Terraform reduces human errors, syntax related issues, and manual steps by automating all these infrastructure provisionings. Then version controls. Terraform itself has an inbuilt code tracking feature so that our infrastructure changes will be tracked in code, whether it is applied or not, or whether it is has any conflicts between your target infrastructure and in your code, so that making us easier to review and revert changes at any time. Then collaboration. Team members can work together on the same infrastructure configurations that will improve the collaboration from every team member, and also it will increase the productivity. Then scalability. Using Terraform, we can easily scale our entire infrastructure, scale up or scale down based on our project requirements immediately. Then finally, multi-cloud. Terraform can manage the resources available across any different cloud providers from single Terraform configurations. It is not like that if you create one Terraform files for AWS, then we can use the same Terraform codes for other cloud providers as well. For that, we need to modify few resource modules and all, and even the providers. But still, the Terraform supports multiple cloud providers. Let's talk about how Terraform works. In order to create or provisioning infrastructure, it is not an easy task because the target infrastructure you are going to create using an infrastructure as a code, then you should be more familiar with the infrastructure, which means you have to be knowledgeable on Terraform as well as the target infrastructure. For example, if you are going to make or provision infrastructure on AWS, you should be aware on AWS what are the resources that would be needed to create it. Then only you will be able to create the record files on Terraforms. So the first one is DevOps or infra engineer who is going to create the infrastructure. He will create Terraform manifest files. Once he has created all these things, then he has to initialize the working directory. For that, we use a Terraform init command. If you are working from a directory and that need to be come under Terraform knowledge, then we have to use Terraform init command. After you have created all these files, we will plan it, which means using Terraform plan command, we can validate and review the changes that is going to be affected before applying any changes on the target environment. It is like a dry run. Then you will do Terraform apply. If you are happy with your validation and review, and if you are sure what is going to be changed, then we can execute the command called Terraform apply to apply the desired changes to the infrastructure. Once this is applied, the end result would be the resource that you have defined in your manifest files will be created on the target infrastructure. But in between, on this manifest file, you will mention your providers. Like, who is your provider? Is it Azure, GCP, AWS, VMware? What is your target provider? That need to be mentioned. Also, we have some kind of provisioners, modules, resources that and all will cover in the later part. First, we'll understand how the Terraform works for now. So once this is applied, obviously you will see some kind of a state file. It is called Terraform state file. Okay, the extension would be .tf state. This is the main file will be created for tracking the desired state. It will hold the entire current configuration state of your infrastructure. This is how the Terraform works. Let's see how to install Terraform on Windows and Linux platforms. So this is my Ubuntu Linux server that is installed with Ubuntu 20. So in order to install Terraform, it is a pretty straightforward procedure. Just go to google.com and search for download Terraform and install Terraform, and the link is developer.hashicorp.com. This is the link. Open this page and you can see various platforms that supports. It supports Mac OS, Windows, Linux, FreeBSD, OpenBSD, Solaris, right? So here, let me show you for Linux. On Linux, it supports Ubuntu, Debian, CentOS, RHEL, Fedora, Amazon Linux, Homebrew. Alright. So as I'm having Ubuntu Linux, I'm going to execute this one. First, we need to deploy the GPG key. Then add the official repository of HashiCorp. Now we can update the repository using apt update command, and parallelly we can install the Terraform package. So the Terraform is installed. So just type Terraform and hit enter. So I'm getting an output of usages, how to use this Terraform command, which means the package is installed successfully, so that we can start creating directory, we can initialize the directory, and we can start creating Terraform manifest files. Okay, now we'll install Terraform on Windows. So this is On Windows, it will be a binary file. Just we need to download this file and extract the zip file. Then just copy this binary file into any executable folders like system32 or something, so that you can use the Terraform command from your command line interface, right? So here is the section for Windows. It is available for 32-bit and 64-bit. So you can choose your platform. So I'll go with 64. I have already downloaded. Okay, so this is the downloaded Windows package file. Just extract this. And open the extracted folder. Here if you see, you have only one executable binary file. Okay, just copy this and go to system32, or even you can set this folder path as your environment path. That's up to you. Alright, the file is copied. Now open your command prompt. Type Terraform and hit enter. So if you see this output, like Terraform usage, then the Terraform binary is available for us to initialize the directory and start creating the Terraform manifesto file. Let me tell you a glance of Terraform how that works. Okay, so in order to create any infrastructure or anything, if you want to manage, then you must have knowledge on the target infrastructure you are going to manage it. So only if you are able to do it manually on the target environment, then only you would be able to create the Terraform for the automations, right? So here, let's take an example that we are going to manage the infrastructure on AWS. So once we are decided, so what are the services we are going to manage it? Like what resources? Are you going to manage EC2 related? Are you going to manage IAM related? So these are services, right? So once we have a plan to create the infrastructure through Terraform, then DevOps or infrastructure engineer will create a directory where we will add number of Terraform manifesto files. So on these Terraform manifesto files, so we will define all the resources that we are going to manage on our target infrastructure. So once you have all these Terraform manifesto files, we have to initialize the directory where you have stored these manifesto files. That is because only if you have initialized your current directory, then only the Terraform will be able to understand that it has to identify all the Terraform manifesto files and that need to take necessary action based on your manifest file. Also, when you are initializing your current directory, that will download the core files that is related to your target infrastructure. For example, so if you are managing your AWS environment, then the Terraform has to download all the required bundles of AWS, and we call it as a Terraform core. So that will have all the APIs related, like how do we use AWS CLI in order to manage your infrastructure on AWS through command line. So we use AWS CLI, right, with some authentication token. Similarly, this Terraform will also download the required packages and will store it in the current directory. That is why we use this initializing. Okay, for that we use the command called Terraform init. So that will initialize the current directory. Alright, so this is the first step we will be doing with the Terraform command, that is Terraform init. Once that is done, we will create Terraform manifest files based on the request. So once the manifest files are ready, then we have to execute the command called Terraform plan. So this command will make sure that what are the changes that is going to be updated on your target environment. This is like a dry run. This will not apply the changes on your target environment. This will go and check your current state of the resources on target environment and will provide you the report like what are the new resources going to be created, what are the changes that is going to be modified, and if there is any resources going to be deleted, that also will show you as a report. So Terraform plan will create some execution plan and will provide you the output that is going to be updated. So once this is done, if you are happy with the Terraform plan output, then we will execute the command called Terraform apply. So this will apply all the Terraform manifest files that you have in your current directory. So this is the main command that we will be using to apply the changes. So this is how the Terraform works. Let's talk about Terraform Basics. First, we need to understand what are the files Terraform has. Alright. So the first thing is, on Terraform files, we will be using the extension called .tf, which is .terraform. Then only the Terraform will understand that this particular file belongs to Terraform. Like how do we have a .py for Python, .yaml for Ansible. Terraform also have these extensions. And the other file is resource state. So this state file will have current state of the resources. Okay, created only when you apply your Terraform changes. Terraform will go to your target infrastructure and get the current state of all the resources, and it will store it in this file for tracking purpose. Also, you could see one more file called tf backup file. That is like a previous backup of your state file. Then finally, we will have a files dedicatedly for variables. That will have an extension like .tf verse. That is Terraform verse. Okay, so you can actually define the variables in your .tf manifest files. But still, why do we have this .tf verse? That is because when you define any variables in this particular .tf verse file, that variable will be available globally within the directory, so that in any Terraform manifest file, we can refer that variable. So that is why we have this dedicated variable file. Alright, so these are the files we have in Terraforms. The next thing is syntax. So we will be using the HCL syntax. Okay, so that will be easy for us to understand the blocks. So if you see, I have two sections I have mentioned over here. That is, one is provider, the other one is resources. Okay, the first thing, when we are creating a Terraform, we have to define the provider. That is our target infrastructure. So as I said, if you are going to manage your AWS, then your provider would be AWS. For that, we need to create a section or block. Okay, you can call it as a provider section, or you can call it as a provider block. So this will be our first section in our Terraform. So that Terraform will understand that we are going to manage the particular provider. Okay, here it is AWS, and within that section we will have some parameters or fields. So like which region, which access key should I use? Okay, those kind of general fields that need to be updated over here. So after this provider, then we will go for creating the actual resources. So resources are nothing but the resources on target environment that you are going to manage. For example, IAM is a service, but within the IAM, if you are creating a user, then that is a resource. User is a resource, group is a resource. If you are attaching any policy to a user, then that is a resource. So all these will be created under this resource. So we can see all these kind of resources in detail in a later topic dedicatedly we have for Terraform resources. Now we need to create directory, we need to create Terraform manifest file. For that, we need a code editor. Why? Because I can create these Terraform manifest with using my notepad or using Vim editor in Linux, but that will not have a feature like autocomplete or auto suggestions. So that kind of features will not be available easily. So we can make lot of syntax errors, typo errors, right? So to avoid that, we have to use some good code editor. Okay, I'll be using Visual Studio Code for throughout this Terraform tutorial series. Alright, let me just quickly go through this Visual Studio Code. Okay, on this Visual Studio Code, you can see an extension option. Okay, here we can install the extension for the project we are working. For example, if I'm going to create Python related projects, then obviously I will create Python files. In that case, I will install an extension for Python so that this particular Visual Studio Code will understand the file and it will provide all the necessary options, suggestions. It will do autocomplete, many more features. Okay. Similarly, as I'm going to create a Terraform related things, Visual Studio Code supports Terraform as well. Okay. So on these extensions, there will be a search box where you can search for a particular extensions. So you can search for Python, then you can install it. You will have a lot of extensions from both trusted as well as the community. We need to go through each extension. So just go through this, check the ratings. If you're happy with that extension, then click on install and you can activate it. Similarly, I'm searching for Terraform. So it is listing all the Terraform extensions. Just go through all the extensions, tell you the features like syntax highlighting and all. If you see these snippets, see, just they are typing Terraform and it is giving all the suggestions. It is auto-completing the syntax. This is why we use such code editors. So here, this is the one I have installed, HashiCorp Terraform, because this is a trusted one. So already I have installed it. On some extensions, even if you have installed it, it will not work. On that case, you have to restart or reopen your studio code. Okay, then that will work. Now we'll create directories here. So this is the Explorer where you can open all your project related. Okay. First, for any project, we have to create a dedicated directory. If you see this, under this Terraform, I have many folders. If you see it in Windows, see these are the folders it was showing on my studio code. Because I have opened this folder in studio code. Either you can create a directory in Windows, then you can open it on studio code. Or from the studio code itself, you can create files, folders, anything. If you want to open any folders or files, then click on that file. Just click on this open folder. It will prompt you to enter your the directory from your Windows. Okay. Just select the folder you want to import and click on select folder. That will be listed over here. This is my directory structure as of now. So for our project, I am going to create an empty directory. From that directory, we are going to create all the files. So I'm going to use a Visual Studio Code itself to create the directory. So click on this box in the empty space. Don't select any of these folders and click create folders, because that folder will be created under this directory. So your directory structure would be, confused. So don't select any directory. Just click on the main box and click on directory, create directory. So here I use a demo v1. So directory is created. If you expand it, it doesn't have any folders or files because it is an empty one. So let's start creating files. The first file I will be creating to define my providers. Then only I will start creating my resources. Okay. So when you create file names, as I said, please give meaningful names so that it will be easy for others to refer it. So either you can call it as a main.tf. Generally people used to create it in the name main.tf, but I prefer to give like provider.tf. Actually the file names doesn't matter. So once you have selected this file, the file will be open on the right side panel. So here you can start writing your resources. So here if you type just provider, that is auto completed my syntax. It started asking me to enter the name. So name is nothing but a provider. If you are managing AWS, then it is AWS. If you are going to manage your Azure, then Azure. So that name we have to give it. Then further within this section, we need to give the parameters. Let's see the list of Terraform providers. So go to Google, just search for Terraform providers. This is the official link of registry.terraform.io. Click on that browse provider link. So here if you see a lot of providers are supporting by Terraform at the moment. Just go through this for your knowledge. And let's click on AWS. So latest version is 5.61.0. Okay, this is the latest version they have. So also you have a documentation. Just go through this. On the left side you will have all the services. If Terraform supports any services, obviously they will list all the services over here. So this is the AWS provider. In the document itself, we have lot of informations. It is more than enough to start writing Terraform manifest files. Okay. Since the first section would be a provider, let's get this provider section. Okay. If you scroll down, they will give you all the usages, parameters, everything. Here they have the syntax as provider, and clearly they have mentioned this particular syntax is supported before 0.13. If you see the other syntax, that is Terraform 0.12 and earlier, then we have to use this below sections. Okay, simply you can copy this section and paste it in your studio code. So already you have a syntax for provider, or just copy the fields alone, or simply copy all the section and paste it over here. Okay, so I have copied everything. Resources, let's delete these resources, we'll take it later. Okay, so this is the provider section or provider block where the provider AWS is already there. If you see, studio code itself is providing some warnings like a version is deprecated and it will be removed in future versions. So you can remove it if you don't want. The next option is region. Obviously in AWS everything is underlying on the regions. So we have to define on which region we are going to use this Terraform. The next thing is, so Terraform is a separate tool and your target environment is on cloud. Alright. So how that both will work? If I say it is a AWS, then if I want to create any user from externally using Ansible, using Puppet or using AWS CLI, then we would need a secret access key, right? Then only we would be able to create or manage resources on AWS. So we would need one secret access key to manage your resources using Terraform. So already I have created one user. Similarly, you can create one user dedicatedly for Terraform. Okay. So here already I have a user AWS CLI. Similarly, you can create one user dedicatedly. Okay. So just click on this kind of users and go to security credentials. So click on this create access key and you can create it. So AWS will provide you secret access key and secret key. And I'll be using this key for my demo purpose. So here, if I want to specify these access key on your Terraform files, in my document itself, I have mentioned the options along with version and region. Okay. If you scroll down, so this is the provider section. You can simply copy this and paste it in your Terraform. Okay. So if you see, version, region are same. Additionally, I have provided access key. So here, then secret key. So these are the two fields we'll be using for specifying the secret access key. But I would suggest not to mention any secret access key in your Terraform code itself. If you are going to store this Terraform codes in a public repository or something, then that will be compromised. Okay. So that is why I would suggest not to mention access keys in Terraform code itself. Instead, AWS CLI supports different ways to use this access key. Either you can go for environment variables. Also, if you install AWS CLI, then that will provide an option to configure it. There is a command called AWS configure. So that will prompt you to enter your access key. That will be stored in your home directory. Okay, there are different ways to manage these access keys. It is not necessary to put the access key in Terraform. So this is relevant to AWS CLI topics. That is why I am telling, if you are going to manage your infrastructure using Terraform, then you must have a knowledge on your target infrastructure. If you search in the Google AWS CLI install, so it will provide you all the informations like Linux, Windows, everything it supports. For example, if I am going to use it on Windows, there is a installer. Just download this installer and just install it. So on the command prompt, you will get an option to configure it. So this is my command prompt, and if I type AWS version, it is providing the version output. So I can go for configuring my AWS CLI, AWS space configure. Then if you hit enter, it will prompt you to enter your access key. So the access key will be stored in your Windows. Okay, it is out of Terraform. So you don't need to specify these fields. I will be managing my AWS access keys using my AWS CLI. Okay, not in my Terraforms. So I don't want to take any risk. Okay, I have removed access keys and even the version that was showing warnings, right? Okay, so this is my provider section. So we have defined the first section. Okay, now let's start using Terraform commands. As we have defined our provider, then we have to initialize the directory to tell Terraform that I have already provided the provider section you can start downloading with respect to my provider. Visual Studio Code itself providing the command prompt. Okay, from this window itself we can execute our command. From here, if you click and drag, you will see the terminals. Okay, from here you can type all your commands. Even it supports multiple terminals that is supported by your Windows. I have PowerShell, Git Bash, everything. Whatever it is convenient for you, you can use it. If you select command, that will open the command prompt. If I use Git Bash, because I have installed Git Bash, because this particular Git Bash software is very helpful for me because I can use Linux commands in Windows. If you type ls, it will provide you the list of files. That is why I use Git Bash. So you can close all the windows. Let me again drag. I will use only the PowerShell. That is a default one we all will have in our system. Now, so it will show you parent directory. Okay. Now we need to get into the directory that we have created. That is demo v1. So use cd space directory name. Once you are entered in the directory, now you can type ls command. So it is showing only the file that we have created, that is provider.tf. Okay, first we'll run our Terraform command, that is Terraform init. This will initialize your current directory. So Terraform will download all your required packages for your provider. It will go to Terraform and it will download all the required files. Okay, so if you see the version, it is showing version 5.61.0. This is the version we have seen in the official document. And once the command is done, if you see, there is a hidden directory and hidden files in the name of Terraform. So within this .terraform only, all the required files will be there for the providers. So this is the main Terraform core. Okay, so we don't need to worry about it, just ignore it. Even if you have deleted, we need to again run Terraform init to download all the required files. So if you see, the Terraform init has done, so it is provided the output like Terraform has been successfully initialized. So you can now begin working with Terraform, which means we can start creating Terraform resources. Okay, the next command is Terraform validate. So this command is not necessarily needed, because when you do a plan, it will obviously, if you have any issues related to syntax, it will throw you the error. But still we have a validate command to validate the syntax. For example, if I make any small mistakes in my file and running Terraform validate, it is throwing the errors. Okay, if you want, you can use it. Okay, so provider is completed. Now we'll start creating the resource files. So if you want to create Terraform for any resources, then again go to the Terraform official website. Then we need to find the resources or modules relevant to your resources that you are going to manage. Okay, for example, if you are going to create any user of IAM, here in the box itself you can search for IAM. It will give you all the results. First start with some basic resource creations. Okay, then only you can go for higher environment, because Terraform is very simple tool, but it can manage very large number of infrastructure. For example, if you want to create a VPC on AWS, just go to browser console, go to VPC service, just click on create VPC. It will prompt you to enter only VPC name and CIDR range. That's it. Your VPC is ready. But still, it has a lot of sub components like subnets. How many subnets you want? One public subnet, two private subnet, or multiple subnets. Then again you need to create NACL. Again you need to create security groups, internet gateways. So a lot of sub components are there. It is not a single component. That is why I am telling again, like if you want to manage any infrastructure, then you should have knowledge on it. So if I want to create VPC in Terraform, then again I need to create VPC is a single resource, subnet is a single resource, NACL is a single resource. So I need to find all the relevant resources that is needed for my project. So let me search for IAM, for example. Okay, here it will show you all the IAM related output. Here under IAM section, you can see all the resources. You can manage access keys, account alias, group. You can add a group into the users. Find the relevant one. Okay, this is how we explore a lot of modules and resources. So this is the one I was looking for, AWS IAM user. Just click on it. Now it will give you complete information about that particular resources. All the resources examples will be provided here along with required parameters, optional parameters. We have to choose which one is perfect for our task. For example, if I'm copying this resource section and pasting in my Visual Studio Code, you can start creating your resources in single file itself, but when it is start growing, it is not easy to manage, right? So that is why for resource management, create a separate Terraform manifest file, not inside the provider file itself. Okay, let me create one more additional file, iam.tf. So why do I create this file? In this file, I'm going to manage something relevant to IAM services. Okay, that is why I have created this dedicated file. Here I just paste my resource section. So this is how the resource syntax will be. We have a dedicated topic for Terraform Resources. Okay, so resource section will be like this only. It will start with the resource. Then within double quote, we have to give two names. One is the exact Terraform Modules or Terraform Resources. So the AWS underscore IAM underscore user, that is the actual resources given by Terraform. So we cannot modify this one. Okay. The other name is resource name. Okay. This is not actual your target environment resource name. For example, if I am going to create a user called John, on AWS the username is John, but on Terraform it has to create one ID for tracking purpose. So here we need to provide a name for Terraform, not your actual resource names. Okay, this is a Terraform tracking name. You can put something user 1, user 2, something like that. Within syntax, going forward you will understand everything. Okay, within the syntax you can define your name. So that user 1 is resource name for Terraform. This is the actual name where you need to provide your actual username. Okay, here you can define John. John will be created on IAM. The next option is path. So here it is like a home directory. You can define your path. Either you can put slash or you can put slash system. Okay. So tags we can remove it. Simply let's create this one section and I will copy this and duplicate it for creating one more user, that is user 2. Here I will mention Karthik. Two resources I am going to create it. User 1, user 2. Okay, now we have a manifest file for creating some IAM resources. In order to validate your syntax, you can go for Terraform validate command. It will validate your syntax. Okay. If you don't have any issues, then go for Terraform plan. So Terraform plan will execute a plan for you. It will go to your target environment and it will compare your resource definition in your Terraform files, and it will tell you the output like the changes, whether it is a new change or it is going to be modified or it is going to delete it. When I hit enter, it is providing me the output like how many resources. It is showing all the resources. If you see the plus, then it is going to create a new user. If you see minus, then that is going to delete the resource. If you see tilt symbol, then that is going to modify the resources. Okay. If you see these outputs, I can see multiple options, parameters, like these fields I have not mentioned in my resource definition. AR and force destroy. Okay. These all required metadata for Terraform for tracking it. Okay. So we don't need to worry about it. If you see this ARN, this is Amazon resource name. Okay. This will be known after apply. So Terraform is saying that this ARN I cannot provide you now, only when you apply. Then only I will be able to see that ARN. That is why it is showing that known after apply. If you see the last line on the plan, it is showing 2 resources to add, 0 resources to change, 0 to. So only 2 resources are going to add it. So now you are done with your plan execution. Okay. Now we can go for Terraform apply to make the changes. Terraform apply. Again it will execute the plan. Then it will prompt you to provide the confirmation. If you type yes, then it will start applying the changes. So I provided the yes. Then it start created and it is showing the creation complete in seconds. So apply completed, resources 2 added, 0 changed, 0 destroyed. That's it. So Terraform applied some changes on your target environment. Let's go to AWS and go to users. And so just refresh the page. You can see John and Karthik users are created. This is a basic resources that we have created for now. Now if you see, when I have executed this Terraform apply, TF state file has created here. If you click on this Terraform state file, it will have all the metadata of your resources. Okay. If you see this under instance, so it is showing all the resources. User 1, Okay, and it will have all the metadata for tracking purpose. If you see the ARN, initially before applying it was showing known after apply. After applying it got the ARN value from AWS and it stored the information in the TF state file. Okay, let's do some changes. So initially we have created the users newly, right, without any changes. If I'm running the Terraform apply, again it will compare your Terraform manifest file and your target environment. If there is no change, then it will show you the output like no changes. It matches your configurations. Okay, let's make some changes. Okay, let me just change the path to /system. Okay, now it is showing that the tilt symbol for the resources, which means the tilt is for modification or update. The other user is not showing because that is matching the configuration. Only if there is a new change or new creation or deletion, then that will show you the output. So this is the field it is going to exactly modify it from old value to new value. Let's do Terraform apply because we are aware of these changes. Now we have one more flag called auto approve. Okay, along with this Terraform apply, because in automations we cannot go and type these kind of prompt. For example, if you are creating the infrastructure automatedly using Jenkins or something, on that case you cannot go and enter yes during the Terraform apply. So that is why we have an option called auto approve. So you can give that Terraform apply, then --auto -approve. This will not prompt you to enter yes or no. Okay, straight away it will consider as a yes and it will start apply the changes. Okay, now if you see I am getting an error, that is because the new path it should begin and end with /. So let me put / over here. This is how we troubleshoot and fix the issues. Okay, apply completed, 0 added but 1 changed. Okay, this is the expected output. Now go to AWS and refresh the page. For Karthik the path is changed. Okay, there is one more command you should be aware of it, that is destroy. Terraform destroy. So this Terraform destroy will delete all the resources managed by this Terraform within this directory. Okay, for example, let's say there is a development environment, the development is completed and you want to destroy or you want to delete all the resources associated with that development environment. Okay, on that cases we can use this kind of Terraform destroy command. This will completely delete all the resources. Okay, let me just execute this Terraform destroy to delete all the resources, and again it is prompting me to enter yes confirmation. So demo v1, this is the directory where I have created all the Terraform manifest files for the topics. So let me confirm my provider.tf where my provider is AWS and the target region would be US East 1. So if you see this iam.tf file, this file I have created dedicatedly for managing the user. That is why I mentioned iam.tf. Okay, and here if you see the resource section, I have two resource section where I have mentioned the usernames and the path. So this is a simple resource creation for the user. Similarly, if you take other resources, like if you want to create AWS EC2 instance, then we will create a resource for that purpose, where we need to define what AMI we have to use, what instance type, on which subnet we have to deploy the EC2, which key name we have to use, does the EC2 instance need any public IP address or not, and on which VPC should be deployed this EC2. So these are some of the parameters we would need when we create the AWS EC2 manually through AWS console. Likewise, we should have all these details in terms of creating resources, right? It is not only for the EC2. Similarly, if you create S3 bucket, then we would need what resources should be used for creating the S3. Also, we would need the S3 bucket name, region and other parameters. So if you want to create any resources like S3, EC2, EBS blocks, EFS file system, VPC, subnets, then we need to find the right resource type. I'm already in AWS EC2. Now if you see on the left side panel, all these are resources. For example, if you want to create only EC2, there will be a resource. If you want to create Spot request instances, there will be a resource. And if you want to create volumes, snapshots, security groups, elastic IPs, load balancers, for all, we have a Terraform resources. So let's take an example that we want to create a EC2 instance. We'll start with EC2 creation, then we'll go for S3 bucket creations. Okay, so first go to Terraform registry official website. Even if you search in the Google, it will take you to this page, and I'm already into AWS provider. And go to documentation, and on the left side you will have all the supported services. So we need to go to the respective services that you want to create or manage, and we need to find the resources that will suit for our task. Okay, if we scroll down, see there is a EC2, Elastic Compute Cloud, okay, where you can see all the resources. Or you can directly search using some patterns. But if you search using the pattern, for example, if I use EC2, the pattern EC2, wherever it is there, it will list all the services and resources. So it's up to us. Either you search using some pattern or directly scroll down to the respective services and find the resources. So let me go to EC2. Okay, expand it. Here if you see, all the resources will be listed over here that is supported by Terraform at the moment. Generally the resource names would be the target infrastructure underscore and the resource name. If you see, as we are managing AWS and we are already inside the AWS provider, it is the resource names are AWS underscore and the resource name like AMI copy, AMI from instance, EC2, right? It is not always will be like the prefix will be the cloud provider. That is based on the name availability. Alright. Mostly the prefix would be the cloud provider. So now we need to find the right resources. Our task is to create a AWS instance. So we need to find something related to AWS EC2, AWS instance, something like that. If you see more resources are similar, then please go through all the resources and read the document and find which is suitable for us. If you are a beginner, let's say, if you see these resources, AWS EC2 underscore host, it looks also like a instance creations, right? So just open new tab. Also, if you see the AWS EC2 instance state, okay, this is just a state like power off, power on, those things. We can ignore it. If you take the other one, AWS underscore instance, this looks like managing the instance. So we can open it as well. So open all the resources that looks like related to our task. Okay, even the AWS underscore AMI from instance, that also looks like creating an instance from AMI. Okay, so you can open it as well and go through each resources. The resources AWS underscore EC2 underscore host provides an EC2 host resources. This allows dedicated host to be allocated. Okay, which means if you use this resource, this will create a dedicated host. If you have a knowledge on AWS, there are multiple hosts, right? On-demand host, dedicated host, reserved host, right? So now we are going to create an on-demand host. So on that case, this resource will not be suitable for us. So this is how we need to go through each resources, understand what is the purpose of the resource and select the right one. If you see the other one, AWS underscore instance, it doesn't have the pattern like EC2 or something, but they have mentioned AWS underscore instance. If you see the description, it provides an EC2 instance resource. This allows instances to be created, updated and deleted. So this is the right resources to create EC2 instance. But it is always not necessary that they will use the exact name in the resource name. So they will create the resource name based on the name availability. If you see the other one, AWS underscore AMI from instance. So on AWS, we can create the instance from AMI itself. So in that case only, you can use directly these resources. So let me close the other one and I will use only the AWS underscore instance. So this is how we choose the right resources for our task. If you keep on creating resources like this, then you will have more understanding what resources I should use for my task. Alright, let's take an example. If you see this basic example, they have different sections like data section. This is data source, okay? Just ignore it. As you are a beginner, no need to get confused with data source and all, okay? I will give you a small glance on this. Here they are filtering the AMI ID from a value. Ubuntu Jammy 22.04, and using this value, they are filtering the right AMI ID from AWS catalog. Okay. Then they are referring that AMI ID in the resource section using the interpolation method. So this is a quick overview of this example. Take this resource example first. Okay. This is how the resource section would be. Resource, then resource name, then unique Terraform ID. Okay. Then they have defined further parameters. So let's just copy this simply, and on my Visual Studio Code, so I have a Terraform manifest for IAM. So I will create one more dedicated file to manage my EC2 called ec2.tf and simply paste the resource section that you have copied. Here they have mentioned only AMI and instance type. Even we have more parameters, right? When you create EC2 instance manually, like we have to select subnet IDs, VPCs, security groups, key names, public IP address and all. They have not mentioned anything here. We will improvise the section from here. So if you go to the Terraform resource page, they will give you all the options available for these resources. Okay. So we have to find the right one. Just go through all these ones. If you see this argument reference, these are the arguments will be supported. AMI, associate public IP address and all. Okay. AMI already they have mentioned, and associate public IP address. Yes. If your EC2 instance is deployed on a public subnet, then we have to enable this associate public IP address. So you will get one public IP address through which you can connect your EC2 instance. Let's create it from the scratch. Okay. So first we need to find the AMI. If you are not sure about your AMI ID, just click on AMI catalog and find the AMI ID, or click on launch instance once simply to identify the AMI ID. Okay. So click on launch instance and which operating system you want. Just select that. I will use Ubuntu, and on Ubuntu I will use 24. So if you select the 24, see, this is the AMI ID. Okay, simply copy the AMI ID and paste it over here. Just remove this value, and within double quote we have to paste it. Then on instance type, so I'll be using T2 micro because that is a free tier, and then the next would be subnet ID, because we have to define a subnet ID where this EC2 should be deployed. So go back to AWS and go to the VPC and find the subnet that you want to deploy. And you can close the launch instance now. Okay, now if you go to VPC, I have one VPC called my demo VPC. And if you go to subnets, I have few subnets, public subnet and private subnet. As I want to deploy my EC2 on public subnet, I will copy the exact subnet ID of public subnet and I will paste it in the resource section. But here they have not specified any keys to manage my subnet ID. So if you type something like subnet underscore ID or subnet, as I use Visual Studio Code, it has the autocomplete feature, so it will suggest you the resources. Or you can go to the Terraform registry and search for the relevant word and go through the all parameters. See, we have the subnet underscore ID. So this is the one I have used. So subnet ID equal to, within double quote, you can use the subnet. So we have used the subnet. Now what else we need? Then we need keeper. Again, go to AWS instance, go to keepers. I have lot of keepers. So select the one you want to use it. I will use this keeper, demo v1. The key would be search for the key or SSH. Yeah, okay. Key name is available. Within the double quote, I will use the exact keeper. If you want to verify that key, again go back to Terraform registry and verify the parameter is exist or not. This is done. What else we need? Public IP address. So associate public IP address. This is a Boolean type. So here we have to use either true or false. If you use true, then public IP address will be enabled. Then security group. Simply type security or something related to it. It will suggest you the keys. Okay, I have one security groups. So within square bracket, you can use multiple security groups with comma as a list. Also, we have one more keys that also will support this security group. That is called VPC security groups ID. If I use the first one, whenever I do a Terraform apply, that will keep on create new resources. If the resources already exist on the AWS EC2, that should refresh the resources. Only if the resources not exist, then only it has to create the resources, right? But if I use the first key, that will recreate the resources. But the second one, VPC underscore security group IDs, this will not recreate the resources. This will create the resources only if the resource is not exist actually. So this is the right key to use it. Okay, let's use the first one and we'll troubleshoot the issue from there. Okay, and go to security groups. Already I have a security group called default SCG, and the inbound I have already mentioned my IP address only to be allowed. So I'll be using this ID. Just copy this ID within the security group list, just paste it. So almost we have added all the required parameters for creating the EC2. We'll apply this Terraform and we'll troubleshoot from there. And one more section we have inside this resource section, that is tags. This will be used only to define the tags in key value pair. Okay, like if you create any tag, any resources on AWS, there will be a tags tab. Here you can see key values, right? Name, environment, anything if you want to refer, you can use a tag section. The same name would be displayed over here, right? So for that purpose only they have this feature. Here they have mentioned name equal to hello world. If I apply this Terraform, the EC2 will be created in the name called hello world. So I will change this to web1. So let's do a Terraform plan. First, to understand, to validate and find the resources that will be impacted on the target infrastructure. Here if you see 3 to add. So what are the 3 resources? Like on IAM I have mentioned 2 user resources and 1 EC2 instance that will be created as a web. If you see this reference name, I have mentioned only web. Sometimes we will create more number of instances. On that case, better you use some unique ID. Okay, so I will change this to web1. If I create another resources like web2, it will be easy for Terraform to track, as well as it will be easy for us to maintain the code. Let's apply the change, and it is prompting me to confirm it. Let's give yes. If you want to override this prompt, you can use the flag called auto approve. Already we have seen this in the previous topics. So it is creating now. So parallelly you can go to instance and see the status. So there is an instance created called web1. It is in running state and instance type is T2 micro. So the instance is created as we expected, as we have defined in the Terraform manifest file. If you select this EC2, that will show you the public IP address. This instance is already in running state, so we will be able to access it if your security group is allowed. So just copy this public IP address and open your putty or any other session manager. Enter the public IP and go to SSH. as we have defined our key pair as a demo v1 to use. So we have to use the key in order to access the EC2 instance. So go to auth, under credential, we have to use the private key. Click on browse and select your private key of your demo v1. These are basics of AWS. Okay, it is prompting me to enter the username and password, which means the network connection between your machine to AWS EC2 is successful. Now this is asking for the authentication. So as we use the Ubuntu flavor operating system, so the default username would be Ubuntu. So I'm able to log in into my EC2 instance, which means, so from here further you can configure your servers. This is our request, right, to create EC2 instance. So we have find the right resources, we have defined all the required parameters, and we have created it using the Terraform. Similarly, if you want to create any other resources like S3, then we have to find the right resources. Let's see that. So again, go back to Terraform registry. Let's close unused other tabs. Go to Terraform registry and search for S3, and here under S3 service, simple storage, here you can find the resources. So S3 bucket. So find the suitable resources, open a new tab and read all the descriptions and select the right one. Here is a resource section, just copy this. Okay, this is a EC2 manifest. Let me create the other one dedicatedly for S3 management. So S3.tf and change and add any parameters from here. Okay, so resource AWS S3 bucket, and for unique name I will use my S3, some unique name. Okay, my S3, then bucket name, and this is a tags. So on name you can use the same name, and if you want multiple tags you can just simply use the key equal to value format to define other tags like environment equal to dev or personal or something. So this is simply other resources for S3. Alright, let me apply the Terraform again. If you see this Terraform apply status, my web1 is destroying and recreating it. Okay, this is because of the security group that we have used during the AWS EC2 resource creation. But in real time, this is not right. Okay, if the resource already exists, it should not recreate it. Okay, it should refresh it. So this is why I suggested to use the next one. So I have identified this issue during my practices. So let's change this security group to VPC underscore security group IDs. Okay, I have changed the security group name. At the same time, I have got an error while applying the Terraform, right? That is related to S3 bucket. Similarly, when you create these kind of high level infrastructure, we will create resource one by one and we'll apply it. From there, if you see any other issues, we have to troubleshoot it. Let's fix this issue. Let's go to S3. S3 is a global resources. The name should be unique in worldwide. Okay, it's purely a name availability. So use something unique one based on your project name or IDs or something. I will use something like my unique bucket name 1, 2, 3, 4, 5, 6. Okay. Even if you have not specified that bucket equal to some bucket name, the AWS itself will create a random bucket ID. Let me command this bucket and let me apply it. Provide the confirmation yes. It is creating the bucket. It's done. So this is how we have to choose the right parameters as well. If you want, use it. If not, ignore it. Go to AWS S3 and refresh the page. I have already existing bucket, that is the old one, but the newly created bucket is Terraform hyphen some random ID. If you see the other resources, we have created two resources, right? EC2 and S3. Let's check the EC2 as well. We have changed the security group to VPC security group IDs. Now it has web1 that is running. The other terminator resources are because of the old parameter we have used. That is keep on recreated. by deleting the old one. Okay, let me again apply the code without changing anything. If you see the instance, it is just refreshing the state. That is why I use the VPC underscore security group IDs. Even if you refresh, it will not have any impact as the resources already exist as per the code. If you want to choose the bucket name, rather than it is automatically created by AWS end, we have to use the field called bucket. Okay, just copy this again, add one more S3. Here just change the ID to my new S3 and bucket, let it be the default one. I don't think the name will be available, so I will give -1. Let the tags will be same. Apply it. Okay, it is applied. Just go to S3 and refresh the page. Yeah, it is created. So this bucket name is available. So this is why we use that field called bucket. If you are not specified the bucket name, that will be created the random bucket name. So better use some unique naming standard, like start with some project name, environment name, or something like that. So this is how we create resources one by one to high level infrastructure. Okay. And if you see any other issues or parameters from there, you have to improvise it. The next one is variables. So variable is very important. We define the variable in one place and we refer that variable in multiple places. If you have the same value in multiple places and if you want to change it in some time, it is not easy to go and change everywhere. You may have the values in multiple files. So it is not easy to maintain it. That is why we use this kind of variables. So we will use a variable in one place with key value and we refer that variable name in manifest files. For example, let's say I want to create multiple instances. Here I have only one EC2 instance, that is web1. Okay, let me create one more resource. Just simply copy the resource and paste it and change the values as per the request. If you see, the first one is for web1, the second resource is for web2. Okay, but since I have the same name, it will not create. So let's change this to web2. Now this resource will be created as a web2. But if you see, in both the places, my AMI ID is same, instance type is same, subnet, key name. Likewise, we will have more same values. So we have to use it in a smart way. Like how do we use these kind of things in a variables? Okay. So it will be easy to change in one place in future if you want. So if you want to create a Terraform variables also has a section. Like how do we have a resource section? How do we have a provider section? Similarly, for variables also we have a variable section. Let me create a dedicated file for variables. So if you want to change any variables, directly you can come to this file and make the changes. So I'll use terraform.tfvars. So tfvars is a Terraform variable file. Okay. So extension is very important here. Okay, here we need to use key equal to variable format. For example, you can use some name, variable name like my AMI equal to my AMI ID. Just copy these AMI ID and paste it in the value. Okay. So here the key name is my AMI and value is the AMI ID. Similarly, you can create multiple variables. EC2 type equal to T2 micro. So this is how we create Terraform variables. Variables are used to define a key value pair. So that will make our codes more flexible and reusable. So once variable is defined, we can refer this variable many times in all Terraform manifest files wherever we want. Okay. So for example, if I want to create 10 AWS EC2 instance with multiple resource section, we can use this variables in all the resources. Okay. In future, if you want to change AMI ID or EC2 instances, you don't want to go and change in all the resource section. Simply you can come to this variable section area and simply change it. This is how it is more flexible for us to use it. We have a different ways to create a Terraform variables. This is the variable priority. So the first priority is command line flags. But see, I have defined the variable in a Terraform manifest file called terraform.tfvas. But still, I can use a command line flag during Terraform apply. Like Terraform apply -var equal to my key equal to value. For example, region equal to US West 2. For example, instance type equal to T2 micro. So that is how I can override my variables. If you use command line flags, doesn't matter even if you have mentioned your variable in Terraform manifest file, the variable will be overwritten. So we have to understand this priority. So we can pass Terraform variables while running the Terraform commands itself. So this is a high priority variable definition. The next priority is environment variables. Okay. So we can set a values for variables using environment variables like export space key equal to value. But on the key, you have to use the prefix called tf_var_. Okay. Then only if you have more environment variable in your operating system, for example, if you take Linux, you will have already existing variables, lot of variables. So we should not have any conflict with that between Terraform variables and other variables. That is why they follow the standard like tf to have the prefix tf_var_ then key. Okay. So this is how we can define the variables using environment variables. If you use Windows, you can use set command, or if you use Linux, you can use export command. The next priority is Terraform variables file. Okay, that is .tfvas. So this is the third priority. If you are not using command line flags, environment variables, then the variable mentioned in the .tfvas will be considered as the actual variable value. We have already created this .tfvas, okay, and we have defined the few variables. If we have not defined any variables in these three methods, then your Terraform will look for a section called variable in all Terraform manifest file. In order to create the variable section, we have to use this format. Okay, so now we have used the tfvas method. So we have defined the variable in key equal to value format. Similarly, I will create a variable section in a manifest file. So why do we combine both Terraform variable? Means I will have multiple choices to select my variables. Okay, I will show you the demo. We will define the same variable in both the files. One is with variable section and other one is on tfvar file. If you have a 10 variables, then you have to create 10 variable section. That will have more information like description, its type and the value, that is a default. So now the priority. So I have used .tfvas, also variable section. If you are not using any variables, finally that will take the default value mentioned in the variable section. So let me create one more file, variable.tf, just to define all variable section. Okay. So variable double quote and curling braces. That is a simple variable section. I will give some name. This is the key value actually. Within the curling braces, you can give your fields. If not, you can simply leave it. Okay. Just to create a dummy variable section. Type equal to string. Default equal to t2.micro. But in TFVAS, I will change my EC2 type to t3 micro. Verify the variable name. It should be exactly match. Okay. If not, there is no use in creating the Terraform variables. So here I have mentioned my instance type. There I have used EC2 type. Okay. I will use my instance type in both the places. Also verify the my AMI. the my AMI. This variable I have mentioned only in .tfs, not in variable section. So please focus on this to understand the priority. Simply, we can create a variable section and simply refer and we can use it, but you should have a proper understanding of the variable priority. We have defined the variables. Now we have to call these variables in your Terraform manifest file. So how do we call the variables in Terraform manifest file? That is where we have the interpolation model. Interpolation is nothing but if you are referring a value from other resources, then we have to call the complete resource name dot key name dot the value, something like that, okay, with dots in between each fields. For example, if you want to change here, okay, where is nothing but variable, okay, where dot then variable name. If you see, if I just type where dot, it is just listing my variable that has a resource section. It is not showing the other variable my AMI because that is mentioned only on TFS, but it doesn't have any variable section. So actually, for every variable you define or create, it should have a variable section. Then only that will be considered as a valid. Okay, so where dot in the sense it is referring some variables. So that variable should have a variable section. Where dot the key name, my instance type. Similarly, I copy this variable and paste it in the other resources wherever you want this instance type. So even if you have a 10 or 15 resources, simply you can manage your instance type from variable. If you want to change, simply come to your variable section and change the type to something else. Okay, let's apply this. See, if you see this web2, it is creating because after we added the resource, this is the first time we are applying it again. That is why it is creating the second resource. If you see the web1, it is modifying. Okay, now go to EC2, refresh the page. Now you should see two instances, web1 and web2. Okay, two running instances, web1 and web2. Okay, I have not changed the name in the tags. That is why it is showing web1. Okay, we'll change it. Next time when I do apply, the name will be changed. Alright, if you see the field, even I have used t2 micro in my variable section, it has taken t3.micro. That is because it has overridden the value of least priority. That is, the variable section is the last priority. That is a default value if you are not have the other high priorities. Okay. The third priority is tf var file, where we have already defined the my instance type, that is t3.micro. That is why the default value t2 micro is overridden with this t3.micro. This is why the variable priority is more important. Let's create one more variable called key underscore name, and let's use this demo v1. On EC2, where dot, it is not suggesting because it doesn't have any variable section. Okay, simply I am trying to give the variable name over here, then see what happens. Where dot key underscore name. Even it is showing in the red line, that is because of the alert. If you see the error, it is saying that it doesn't have any variable block, that is variable section. So that is why we suggest combine both .tf verse and variable section. Okay, on variable section use default values for safer side, and on the tf verse it will be easy for you to simply in single line with key equal to value you can manage all your variables. Like how do we use variables in shell scripting, Python and other programming language. Okay. So simply create a dummy resource line. Okay, let me use command line flags terraform apply -var equal to key underscore name equal to demo v1. See, this feature also not supporting. Again, it is saying that it need a variable section. Okay, that is why I suggested any variable, if you are referring in your Terraform manifest file, that should have a variable section. At least you should have create a dummy variable section for the resource. Let me remove all variables that is not needed. Okay, let me revert back all the changes. Okay. Okay, the next topic is outputs. So output is nothing but while applying the Terraform, many resources will not be known to the Terraform. That will be available only after applying on the target infrastructure. On that case, you have to log into the target infrastructure and find the resource values. For example, you have created the EC2 instance, and if you want to know the public IP associated to the EC2 instance, you have to get it from the AWS console. So it is not like every time you have to log into the console and get the details. Using this Terraform outputs, we can get the values directly on the terminal itself where you apply the Terraform. Okay, that is why we use Terraform outputs. So Terraform outputs also we have a section block. Like how do we have a resource block, variable block, provider block? So this is output block. Okay, simply create output space some name, because the value will be assigned to this name. It is like a variable. Okay, my web1 public IP and value equal to, we don't know this value, right? So how do we get this value? So what you have to do is, here we can use again an interpolation model. Okay, for example, if you want to see the public IP of web1, you have to go to the resource section, and from there you have to use the interpolation model. For example, so AWS instance, then web1. So we have to use AWS instance dot the specific ID dot then the field. Just command this for now. Let's run Terraform plan. If you see the resources, there is interpolation. AWS underscore IAM user, that is a resource name, dot then specific ID of Terraform, right? User 2, user 1 and all. Okay, we can use this format for output. And if you see, every resources has its ID, unique ID. Okay, if you take this instance ID, this is also known after apply. Okay, if you want to see this instance ID on the terminal itself, then we have to call the ID. If you want to see the IP, we have to find the right value. Okay, here you follow the interpolation model. AWS instance, the resource name dot the resource ID, the unique ID what we have used in the statement, then dot the actual key. Here I will use public underscore IP. So how did I find this value? I'm not using ID. I'm using public underscore IP. But the public underscore IP is not used anywhere. how did I get this public underscore IP field means whenever we create a Terraform apply, that will create a Terraform state file where Terraform will maintain all the resources, correct? So the Terraform state file will have all the metadata of your resources. If you go to Terraform state file, go through this. For every resources, we will have more informations. See, this is the web one. Under this web one, you have lot of information. CPUs, memories, ID. If you want to refer ID, you can use the field ID. And here if you see private IP, public IP, this is the key value I have used over output section. Okay, let me copy this output section and let's get the instance ID of web2. Similarly, you have to change the value, okay, based on interpolation. So it has to go to the resource called AWS instance.web2, then ID. Okay, now this is not a string, okay. So as this is a interpolation, you should not use strings. Okay, so remove the double quote. Let's apply. If you see after applying all the changes under outputs, it is giving me the public IP of web1 and instance ID of web2. So I don't want to log into AWS console to get my IP and login. Okay, simply I can copy this IP. From here I can do anything I want. This is why we use output section. If you want to create an infrastructure like AWS VPC or any huge infrastructure, so we need to list out and create everything based on the architecture. So when you look at this architecture, we are not just creating a VPC. There are multiple resources involved in it, like subnets, route tables, security groups, internet gateway. So we need to identify or list all these first. After that, we can see which resources are suitable for Terraform, and we will write our manifest file accordingly. Since we are focusing on the VPC, I am going to create a dedicated file called vpc.tf. Also, I have already commented out our previous manifest as our focus is only on VPC. And in the provider section, if you see, I have specified US East 1 since I am creating the VPC there. So we have created a file called vpc.tf. So in this file, let's list out all our resources. The first resources we need to create is the VPC. Then next, based on our architecture, we need to determine how many subnets that we need. In this case, we will have both one public subnet and one private subnet. So if you want to create a public subnet, we will need an internet gateway. Then only it is called as a public subnet. So we will add that as a second resource. Let's take the third resources. See, we have created the VPC and the internet gateway. So the main resources we need here is subnets. So if you look at the diagram, we require two subnets, right? One is the public subnet and the private subnet. For the public subnet, I will create a resource called public subnet 1. Next, I will create the private subnet, which I will call private subnet 1. Now, the fifth resource is for each subnet, we need to create a route tables. So route tables are essential because they ensure the traffic is forwarded correctly. So I will create one route table for each subnet. For the public subnet, I will create a route table called public route table 1. Okay, public RT1. So similarly, I will create the other resource called private route table 1, that is for private subnet. So at this point, we have created 6 resources. If you create multiple subnets, you must associate the relevant route tables with them. Then only the traffic will be forwarded to the correct subnets. So when we attach an internet gateway to a subnet, then that subnet will be a public subnet. So for public subnet 1, I will set up the internet gateway attachment. So we will not attach the internet gateway to the private subnet. If you attach the internet gateway to a private subnet, then that private subnet will also behave like a public subnet. So that is wrong. So we have to attach the internet gateway only to the public subnet. the association between each resources is more important. So public subnet 1 association. Okay, and this public subnet 1 association I will be using to attach my internet gateway to the public subnet. Similarly, I will do the same for private subnet, but here I will associate private subnet with the corresponding route table. I don't attach any internet gateway. Anyway, I will list the resource like private subnet 1 association. As per this list, almost the VPC and the main components will be created. So finally we will deploy the servers. For public subnet, we will deploy public facing servers like web servers. And for the private subnet, we will generally deploy the backend services like database or any application servers. Right? So we will be deploying two servers, one web server in the public subnet and one database server in the private subnet. So when we create EC2 instance, we will also need a security group. So security group are very essential to control the access rules such as inbound and outbound traffics. Now, for the next resource, I will create a security group called SG1, security group 1. So this will allow access from anywhere, but also I will restrict some access to my specific IP as needed. In EC2, I will mention a server for the public subnet called web server 1. Similarly, I will create another EC2 instance for the private subnet that will be called as DB server 1. We have a total of 11 resources to create now. So this is the concept we are going to follow. So let's identify all the resources that we have listed here from Terraform. Let me comment out all these lists. I will start associating each resources accordingly. So already I have opened Terraform registry. The first resource on our list is VPC. So search for VPC. Mostly it will be under Virtual Private Cloud. So just expand it and use the respective resource. Already we have covered all these topics like how do we choose the right resources from Terraform, right? Okay, so this is the right AWS VPC resource that will be used to create VPC on AWS. So here is the syntax. The resource name is a VPC reference name and it provides a CID block. So this is what we need. You will have many options available in this specific resources. Instance tenancy, DNS support and many more options like this. So we have to choose the right options if you need anything additionally. So I will just copy this basic syntax and I will paste it under the list. Okay. If you see here, the resource name, you cannot change it. So this is a reference name. This is an example. As we have copied from the Terraform registry, they have mentioned like main. Then we have to give some unique name like VPC1 and VPC2. So that will be easy for us to track. Okay, so I have given VPC1. The CID block is 10.0.0.0.16. So let it be the default value. From there, we are splitting the subnets like one series for public subnet and two series for private subnet. Even if you create the VPC manually, obviously this will ask you to enter the name and CID block. And in the statement, we have not defined any names, so the name will not be created. So we have to define the name manually using tags options. If you check at the Terraform, there is a syntax for defining the tags. So just copy the tags and paste it inside the section. Here in the name, you can give some name. Let's say take an example like you are creating this VPC for a Coke customer or a Flipkart customer. Accordingly, we need to define it. Then only if you go to AWS and listing all the VPCs, it will have a unique names. Also, I will add one more tags called managed by Terraform. So if anybody going and seeing the tags, it will be mentioned like it is managed by Terraform, so nobody would change it manually. Otherwise, you can keep your team name like managed by dev teams, DevOps teams. This is a general practice we follow. When you create such high-level infrastructure, create each resources one by one and apply it. If there is any issue, you can resolve it. So overall, if you write everything and if you do apply, you will encounter multiple issues, then it will be challenging for you to resolve it. That is why I suggest create each resources and apply it, then resolve the issue if you have anything. So let's Terraform apply. So it is applied. Let's refresh the VPC. So as expected, the VPC is created and we have given the name in the tags, that is Coke VPC. If you have not specified the tags, this name will not be appeared here as expected. So then we will get confused. That is why we suggest you to follow all the practices. So as we expected, the VPC has been created and the CIDR range is created. So the next resource is Internet Gateway. So we are going to find out the resource for the Internet Gateway. Now, if you look here, try searching for something like Internet. So it will show you all the list that is matching this pattern. So there is an Internet Gateway resource. I will open it. So if you look here, the resource has a resource name. They have given a unique name for the gateway. If you look at this Internet Gateway, this Internet Gateway is attached to a particular VPC. So even when we create it manually, the same concept applies. Okay, so we have to attach the Internet Gateway to a VPC ID. Okay, just copy and paste it here and just update it whatever we want. On the unique name, I will just make it Internet Gateway 1. On the VPC ID, we need to call as per our section VPC resource we have created like AWS underscore VPC, then VPC 1. So we have to change it accordingly. So the ID will be automatically associated. And if you look at the tags, the main one is general, since we have copied from Terraform registry. So we are creating this VPC for Coke customer, right? So I will create it as Coke-Internet Gateway 1. Similarly, I will provide managed by tags as well. Okay, save the manifest file and let's do the Terraform apply. Okay, the apply is completed. Let's go to VPC and refresh the page and go to Internet Gateways and see the Coke Internet Gateway 1 is created and it is exactly attached to the VPC ID we have mentioned in the section. Here if you see, we need to do some improvisation over here, like for every resource we are using the tags called Coke. So when you create multiple resources like 10 resources or 20 resources, then you need to mention everywhere. So that's why we are using a variables. We already have a variable.tf file where I have mentioned a variable for my instance type. So again we need to create a section called variable. So already we have covered Terraform variables in the previous discussions. Okay, variable client name and variable managed by. So I can use these variables in any Terraform manifest file further. If you want to give any default values, you can give it or you can ignore it. Let me give some default value. I'm going to completely manage these variables in terraform.tf verse. Okay, I'm creating this variable section now only for dummy purpose. If you don't have a variable sections, you will have an error from Terraform. Like there is no variable section for a variable you have referred, right? That is why I just creating this variable section. So let me give some default value, like default. It doesn't matter for me. I will manage everything through tf verse file. Similarly, for managed by, I will give default equal to some names like DevOps. If I didn't any values in tf verse file, then obviously this default value will be applied. Let's go to tf verse file. Let's define the client name equal to Coke and managed by equal to Terraform. Now go back to the VPC Terraform manifest file. We need to update the names along with the respected variable names. So I will use dollar parenthesis and within the parenthesis I need to give the respective variable name. So as I have given client underscore name, the value of client underscore name in TF is cope. So this resource will be created like cope-vpc. So if I want to change my client name, I don't want to go to every resources and modify the values. Simply I can come to this TF and I can change the client name to something else. And if I do apply, the names will be changed accordingly. Also I will change the managed by as a variable. I will copy this tag. Similarly, I have to use in every sections. Let me copy the name and managed by. And if you see this name, it is not a VPC, it should be Internet Gateway 1. As I said before, in case if you want to change the client name, simply come to this TF and just change the client name or any other variables. So this will save us a lot of time. Let me apply this. Alright, so we got an error like managed by and within double quote. Okay, I have mentioned the variable within the double quote. So this will consider as a string. So it will print as it is. Since this is a variable, we have to use var dot then variable name. Then only the particular variable name will search for variable section and the value will be applied. Okay, done. Save the changes and apply it again. Now go back to console again and just refresh the page and make sure all the changes are there as per our Terraform manifest file. Alright, now let's go and create the other resource. That is public subnet 1. Let's go back to Terraform registry and find the respective resources. Search for some pattern like subnet and it will list out all the matched result. Okay, it should be under VPC. Let's use this AWS underscore subnet. They have mentioned the unique name, VPC ID, and the subnet should be attached to VPC ID and the CID range for the subnet. Okay. So just copy this, paste it over here, then make the changes. So let's change this unique name to something else. Since it is a public subnet 1, I will give pub underscore subnet 1. VPC ID. So again we have to use the interpolation model. Already we have used the same VPC ID reference in Internet Gateway. So just copy that. And CID block. As per our environment, public subnet should be 10.0.1.0/24. Already it is there. So let's not change anything. And for tags, let me copy from the previous section. Just change the name to public subnet 1. Then only this particular resource will be created with the cope-pub underscore subnet 1. Okay, so we have defined the resource section for public subnet 1. For private subnet also we are using the same resource. Okay, only difference is we will not attach the internet gateway. So just copy this syntax and paste it under private subnet 1. Now just make the changes. Here on the name, instead of pub, it should be private. So just change it to meaningful name, private underscore subnet 1. So VPC ID is perfect because this subnet should be attached to the VPC ID that we are creating through Terraform manifest file. The CID block range would be different for each subnet, right? For public subnet, we have used 1 series. For subnet, private subnet, it should be 2 series. And tags, yes, we need to change the name. It should be private. Okay, let's apply this. So it is applied. Let's go back to VPC again, refresh the page and go to subnets. Already I had some default subnets. Along with that, we have got our newly created subnet for Coke. And both subnets are attached to Coke VPC. If you click public subnet 1 and go to route table, see there is no route tables here. These route tables are default route tables created for the specific VPC. Now we need to create the additional route tables. Again we need to go to Terraform registry to find the right resource. Let me search for route and here it should be under VPC obviously. Okay. Here route table. Here if you see this example, they have route table and multiple sections. So obviously the VPC ID will be there because we need to attach the resources to a specific VPC ID. After that, if you see, we have a route. So this route is connected to a internet gateway. So when you attach an internet gateway to a subnet through route table, that subnet will become a public subnet. That is why we attach this gateway. We have another route record that is for IPv6. We don't want these route rules. Okay. Then tags. Just copy this entire section and paste it here. From here, we will update it. The first thing, we will change the name. Since it is a route table, I will give public route table because this route table will be used for public route table. For VPC ID, let's use the same VPC ID interpolation model. And on route, we don't want this IPv6. Let me remove it. On this route table, so we have to attach the internet gateway to a public subnet through route table. That is why we need this route section. On the CID block, it should be like 0.0.0.0 because this is a internet gateway route rule. Anybody can access to our public subnet from anywhere. So we will generally give 0.0.0.0. If you see my default public subnet, see the route table 0.0.0.0. They have mentioned for internet gateway. Anybody can access it. So how do we restrict access? It should be handled through NACL, that is network ACL or security groups. On gateway, again, this is the interpolation model. Already on the second resource, we have created the gateway resource, internet gateway resources. So we have to call the respective internet gateway ID through interpolation. So obviously we will use the AWS internet gateway. The name is internet gateway 1. So we have to change it accordingly. So the name should be internet gateway 1. Now the tags. Simply copy the previous tags, paste it here and just change it. And this is a public route table 1. Okay, next again it is a route table, but this is a private route table. So simply copy the resource section from public route table 1 and paste it here and do the changes. The name should be private. VPC ID is same. For private route table, we don't want the internet gateway attachment. If you attach this internet gateway to a private subnet through private route table, then it will be a public subnet. So don't do these mistakes. Okay. So let me remove this. We don't want this attachment. And tags, just make the changes. I'll call this as a private route table 1. If you go and check my existing private subnet, see, it has only the default route rule. I don't have any internet gateway. Similarly, I am following this practice. Okay, so now we have created the route table resources, public route table and private route table. So let's apply these changes. It's applied. Now again go back to route tables and refresh the page to make sure the route table is created or not. Now we have a public route table and private route table, and now we need to verify all the things like whether the attachment has happened correctly or not. So just select the public route table 1 and see the internet gateway is attached and it is 0.0.0. This is expected. If you see the private, there is no internet gateway. Now we have created the subnets. Also we have created the route tables. Now we need to associate the respective subnets and route tables. Then only the traffic will be forwarded to the right subnets through this route table. If you see this public route table, there is a tab called subnet association. Here we generally select the respective subnet using this edit subnet association. Similarly, we have to use the same subnet association using Terraform. So we are going to associate the public subnet 1 with public route table 1. Same way, we are going to associate the private subnet 1 with private route table 1. Let's go again back to Terraform registry and search for subnet or association. Okay, let me search route because the association will be done through route table. Okay, under VPC, if you see, there is a AWS route table association. Okay, these are default and main route table association. We have to use a dedicated route table association. Click on this resource. See the example. As usual, they have the resource name and some unique name. They have mentioned A, and here simply they have mentioned the subnet ID and route table ID to associate. Simply copy and paste it here. Just update these resource. On the name, I will mention like this is for public subnet 1 route table 1. So I will use public subnet 1 underscore route table 1. So be clear with this. This route table is for public subnet 1 and route table 1. Here they are using the interpolation model. Already you have created the subnet and route table in the previous resource definitions. Simply you have to call the interpolation model and update the values here. Just scroll up and see the exact name you have given. It is pub underscore subnet 1. For private, I have used priv underscore subnet 1. Okay. Instead of foo, just update pub underscore subnet 1. Similarly, for route table, again, find the correct name you have given. Here I have given pub underscore route 1. Similarly, I have to update it here. That's it. This will associate your subnet and route table. Simply copy this and paste it for private subnet associations. Here I will change the name. This is for private subnet, so I will change it to PRI, and we have to update the respective subnet ID and route table ID for private. Here I will change it to PRI. Here also I will change it to PRI because we are following the same naming standard. Now we are defined the resources for associations and let's apply it. It is done. Now go back to VPC and so let's refresh it. Select the public route table 1 and go to subnet association. Here if you see, as we have defined in the Terraform, for public route table 1, public subnet 1 is attached. This is what we expected. Similarly, if you see the private route table, the private subnet 1 is attached. As per our infrastructure diagram, we have created the VPC, we have created the internet gateway, then route tables. Also we have created public subnet and private subnet. So almost we have created all the components that is needed for this VPC diagram. Now we need to test it using some servers. So we have to deploy EC2 on public subnet, also on the private subnet. So 9th resources, I have mentioned like security group. Then only you can handle your traffic. That is why I have mentioned the security group before creating the instances. Let's find the right resources here. Search for security or something. Under VPC, there is a default security group. Also, we have a security group. Okay. We are going to create a new security group, not default. So, we have to use this AWS security group. So, this is the basic example of creating the security group. If you see the security groups, manually if you are going to create it, what is needed? Two things. One is inbound and outbound. Inbound is nothing but the traffic coming to your security group. Outbound is nothing but the traffic going outside of your network. So generally we will restrict or give more control to inbound. Then only we can manage or control our traffic. Who is needed to access our network. Outbound is nothing but we are trying to access outside the network. So it can be 0, 0, 0, 0. That doesn't matter. So inbound and outbound on security groups. But in Terraform, they refer it like ingress and egress. For inbound, they refer it like ingress. For outbound, they will refer it like egress. Similarly, if you want to give any rules like inbound or outbound, you need few values like type and protocols and port numbers and the source. Okay, if you see the example, that is a name, security group, and allow TLS. That is just a name. We can give anything like security group name and name. This is just a description, like when you click on the security group, that will have some description to identify why do we create this security group. For that only they have this description field. If you want, you can keep it or you can ignore it. Then VPC ID. Obviously we need to attach the resources to a specific VPC ID, so they have this value. Then tags. Okay, if you see these resources, they are creating the security group, but they don't have any rules like for inbound and outbound. For that only they have additional resources to create the rules. If you see from port, IP protocol to port, which security group. So these are the required fields that we need to add in a rules. Also we have another formats. Instead of using a dedicated resource for creating a rules, we have a pattern called egress section and ingress section. That also can be used. Both will support. Which is easy for you, you can use it. Okay. You can go with resource section, or simply within the security group you can use ingress and egress section. I will use this format. So it will be easy for me to understand that within the security group I have following ingress and egress sections. This is for egress, which is outbound, which is outbound. If I change this to ingress, then that will be for inbound. Simply copy this section. First let's create a security group. Copy this, paste it over here and make the changes. Here on the name, I will change it to some unique name, something like security group 1. Name, I can give SG1. For description, I will comment it now. VPC ID, let's copy it from previous sections. For tags, you can give the names. Just copy these tags and paste it here. Okay, let me copy from other section. Now we need to define the rules. Within this resource section, I am going to use the egress or ingress sections. Just copy this format. It's up to you. Okay. Paste it here. This is egress. That is outbound. Similarly, I will paste one more time. Here I will change it to ingress. So inbound and outbound. Here we are going to update our rule. But I will limit with my IP because nobody will access it. Generally we will not give 0.0.0. So this will compromise our network. On this CID block, I will change this to, if you see my existing default group, I have limited with my own IP. I will paste it here, which means allows all the ports only to my specific IP address. Nobody else can access this network from all the ports or from anywhere. Okay. We don't want IPv6 CID block. Let me remove this. Okay. If you see this CID block, it is a list because they have mentioned in a square bracket. So it is a list. So if you want to add multiple IPs, simply you can give comma and you can give n number of CIDR ranges. What I will do is I will add one more CIDR range. Generally we will give CIDR ranges, okay, 10.series or some IPs. So similarly we need to follow the pattern. So here I will use, instead of specifying the CIDR range manually, I will use the interpolation model. AWS underscore VPC.VPC1 dot, instead of ID I will use the CIDR block of my VPC. So if you see, I have used the CIDR interpolation model. So it will go to the resource block and find the CIDR block range, and that value will be applied over there. So from anywhere people can access it only from my IP and VPC range. So inbound is done. Egress. Outbound is generally, it will be open to all. It will not harm anything. So let it be default. For now, let's apply this. It's applied. Now let's refresh the security group. Coke SG1 is created. If you select this, under inbound, see there is a 2 rules. I have created only one ingress. On inbound, I have mentioned only one route. But here if you see, it has 2 resources. That is because on CAD block, we have mentioned 2 CADRs. For each CADR, that will create a rules. For my IP itself, it has created one rule. For CAD block itself, for VPC CAD block itself, it has created one rule. If you want to restrict with some specific port, you can give it. As I have given 0, it will be considered as all port. If you search for this, somewhere they have mentioned, if it is 0, it is for all. Only if you go through this document, you will understand all this. So I am going to create one more inbound with restricting the port and protocols. Simply copy the ingress. Here in the CAD block, I will give 0.0.0, which means anyone can access my network. But I will not simply leave this because I need to restrict it. For public subnet, it is a public web server. So obviously people have to access it through HTTP or HTTPS. Then only people can access it. That is why we mentioned this 0.0.0. Also we will specify the port. Simply we will not leave it to anyone. So from port, I have to give only 80. So anybody can access to my network through port number 80. To port, again 80. On protocol, as I said before, the protocol format is, let me simply search. On the protocol, if you see -1, then it is equivalent to all. Doesn't matter TCP or UDP, it will be considered as a all. That is why we mentioned -1. Let me use -1 and apply it. In case of any issue, I will change this to any. Only that should support both port protocols like TCP and UDP. Then only you can use -1. If the port is not supporting both protocol, then there is no use of using it. Right? That is why we have got an error now. These are all network concepts. If you want to use -1, then both the ports should be 00. Then only we can use -1. Because it will have a combination of TCP and UDP. As we have used a specific port, I cannot use -1. Either you have to be specific with the protocol. You can mention TCP or UDP manually. Simply save this change and apply it. It is applied now. Let's again go back to security group and refresh it. Click on security group 1. If you see, we have one more rule added. For public, it is allowed to use only port number 80. This is how we add each rules. So security group is done. Now we need to deploy the servers. Web 1 will be deployed on public subnet and DB1 will be deployed on private subnet. For creating this EC2, already we have dedicated Terraform manifest file called ec2.df where we have a resource section. Already I have commanded it. So let me copy this, paste it over here, simply update it. If you want, you can take it from the registry as well. Okay, here just make the changes. Let it be web 1 and AMI using Ubuntu 20 and I am using AMI ID of Ubuntu 22 and instance type. Already I have referring some variable. It's where.my instance type. It is already mentioned in my variable section and it is T2 micro. In TFVAS also I have mentioned the T2 micro. So automatically that will be applied. For subnet ID, this is web 1, so it should be on the public subnet. It is already mentioned. And here I have referred the interpolation order. It is already public subnet 1. Generally I follow the standard. In case it is different, just go through your resource section and find the right name and apply it. Here if you see, it is public_subnet 1. So I will use the same name here. it is correctly mentioned, and key name and associated public IP address. Yes, I need it. That's why I mentioned true. Then only I can access my server on public subnet through public IP. Then only I will be able to access it from outside. And security groups. The name is SG1. Again, it is same. Tags. Simply copy the tags from previous section and paste it here and make the changes. It should be web1. It's done. Just copy this resource. Again, paste it for DB server. But here I will make some changes since it is a server to be deployed on private subnet. So just change the name. If you want to change any AMA ID or instance type, you can change it accordingly. And here on subnet, it should be private subnet. Then only the subnet, the EC2 will be deployed on specific subnet. And since it is deploying on private subnet, I don't want public IP address. There is no use of it. So simply you can delete it. On tags, I will change it to DB1. Okay. Before applying this, I have an output section. So on terminal itself, it will display my IP or any other resources I want. Okay. So already I have mentioned in the EC2. So simply I will copy, paste it here. If you want, you can use this output section. We have already covered all these topics. So I am simply asking Terraform to show me the public IP of Web1 and private IP of Web1. So I will copy this output section again to list to show my private IP of DB server. DB server will not have a public IP. So I will use only the private IP. Okay, apply it. Meantime, you can go to instance. Okay, it is created for Web1 and DB1. It is created, and it has shown the IP of each EC2s. Let's open the putty and use the public IP or credential and use the key that I have mentioned in the resource section. Username is Ubuntu because I am using the Ubuntu AMI. Yes, I am able to log into server that is deployed on public subnet. I cannot access my DB server that is deployed on private subnet because that is not a public facing. This is how we have created the entire infrastructure. If I want to access my server that is deployed on private subnet, I can't obviously access it from my outside the network. I have to access it only from the public subnet. There is no public IP. Only I have a private IP. Okay, internally I can access it. So simply copy this IP. Just use ping and the server IP. See, I am getting the reply from private subnet server, which means internally I am able to access it. That is how the architecture was designed. And accordingly, we have created the Terraform manifest files. Also, I will install Apache for testing my security group port number 8. I have updated my package. So I will install the default Apache now. It is based on your application. I am just testing my infrastructure. Okay, let me restart the service. Okay, now If I access it, I'm able to access my default Apache landing page. So completely, we have created an infrastructure through Terraform manifest files. For this, we have associated lot of resources. So this is the directory demo v1 we are using for the demo. And this is the file vpc.tf used to create the AWS VPC architecture. For example, in order to create an entire AWS VPC architecture, we needed a minimum 9 resources. So for creating each AWS resources, we have identified the respective Terraform resources and we have defined in our Terraform vpc.tf file. So first let's go through this file first. So obviously in order to create the AWS VPC, you would need the CIDR block. So this is the first resource, we will create it manually. So we have identified the respective Terraform resources from the Terraform registry and we have defined the statement over here in order to create the AWS VPC resources. So also we have implemented using tags along with variables. So these are basic topics already we have covered in the previous session. The next resource we have used, that is Internet Gateway. Then followed by that we have created the public subnet 1 and private subnet 1. So one public subnet and one private subnet. And also we have created the route table that is needed for the subnet, like public route table 1 and private route table 1. Also we have used the Terraform resources to associate both public subnet and public route table. So that is why I have mentioned that public subnet 1 association, which is nothing but we have associated public subnet and route table. Similarly, I have associated the private subnet 1. For that also I have defined the statement. Then we have created the security group where I have allowed my IP address. So this is the overall VPC Terraform file. Finally, we have created one EC2 and deployed in this VPC. In order to create a big infrastructure like AWS VPC architecture, you needed minimum 9 resources. So in order to create these 9 resources, we have identified the correct Terraform resources from the registry and we have implemented it individually. To make this easy, we have the Terraform modules. So Terraform modules are like units, reusable units that are very well organized collections of Terraform resources. Okay. So this will really help us to manage any kind of complex infrastructure by grouping these kind of related resources. So by using these Terraform modules, we can simplify our code and we can share the same configuration across any different projects. Already group of developers have created these Terraform modules and pushed into Terraform registry. So we can make use of those Terraform modules in our codes. So if we use Terraform modules for the same AWS VPC architecture, we can create the same setup with less than 10 lines. In short, Terraform modules is a reusable units. Already people have created these Terraform modules. We can use the same Terraform modules for our purpose. In your search engine, if you search for Terraform modules, here there will be an official link from the Terraform website. So here is a link, browse modules. Let me click on this. If you see, this is the modules page. If you see this website, we have multiple tabs. Okay. So here if you see there is a providers. So it will give you the list of providers being supported by Terraform. Okay. So provider is nothing but the target infrastructure. Here we use AWS. If you click on this AWS, see there is a documentation. Here you can see all the individual resources available for AWS. Here we find the respective resources individually and we have copied the code and implemented in our existing Terraform files. If you want to create a single resources, then obviously you can go for Terraform resources. But if you want to create a big setup or big infrastructure, if you have the option available in the Terraform modules, then we can try using the Terraform modules. Let me go back to the main page. Here, next to the providers, there is a modules. You can use these modules, or in the search option itself, we can search for the modules. Let me click on these modules first. On the left side, you have all the providers. You can select the particular provider and go for the modules. So here, this is one module, Terraform AWS Modules /IAM, which means in IAM service itself, we have a lot of resources. We have user, group, policies, roles. If you want to manage complete IAM services, then we can try these modules. If you want to just create and manage user, then that is a single resource. For that case, you can go for the Terraform resource. But if you want to manage the entire IAM, then we can go for modules. If you see the other module, Terraform AWS Modules /VPC. Here you are going to create or manage the entire VPC, including all the individual resources. So likewise, we will have many modules. So this is like a solution for creating the big infrastructure. Somebody have created a modules for us so that we can also use it. For example, let me open this IAM. Also, I will open the VPC. But anyway, we are going to use a VPC, but still we will go through these modules. Even you can search the modules directly over here if you are looking for some specific services. So if you search for VPC, this result for providers, and below that, see there is a module section. If you see, this is a Terraform AWS module /VPC, which means this is officially supported by Terraform. But also an individual or single developer also can be contributed. That is why we have these cloud posts /VPC and all. See, we have many companies or individuals have been already contributed. Okay, let me open this IAM and VPC. Here you will have all metadata information like who is managed and where is the source code. And if you scroll down, you will have all the examples and help. See, there is an example. So it starts with module and VPC. This is how we need to use the structure if you want to use this particular module. So if you see, there is a source. Here we have to mention from which Terraform module and which resources. And these parameters like name equal to my VPC. So here, instead of my VPC, you can use any name that you want. Also, to mention the CIDR block, they have the parameter CIDR equal to and the value of CIDR that we need to create it. And also we have the parameter to specify the availability zone. So you can specify where you want to create this VPC. Also we have the parameter to define private subnets. Similarly, we have a public subnet. And if you want to enable the NAT gateway, we can define this parameter and say true. Similarly, we have an option for VPN gateway. Also, we have a tags. See, with this number of limited lines, we'll be able to create entire VPC architecture. For example, in this module C, there is a parameter we have defined CIDR equal to the range. For this line itself, we have used a resource, individual resource called VPC, and for that itself, we have mentioned some 5 lines. Similarly, for private subnets, they have mentioned 3 private subnets. For single private subnet itself, we have used this much of numbers. If you want to use 3 private subnet, we have to replicate these into 3 times and we need to modify the CIDR block. For example, I can say it is a 1. I can say this is the range of 2. So I need to create 3 statements if I want to create it individually. But here in this module, it is a single parameter where they have used a list option with comma. Similarly, they have used the parameter public subnet. But if you see here, only 2 lines, that is reduced our work in simplifying the code instead of specifying 6 statements. Similarly, we have a NAT gateway, we have an internet gateway option, we have a VPN gateway option. In our example, we have created AWS Internet Gateway. Another smart feature of this module is when you give public subnet parameter, automatically one internet gateway will be associated. So we don't need to specifically mention to enable internet gateway. That's how smart it is. Let's use the Terraform provided modules VPC. Let's copy this. So already we have a VPC in our demo V1. So let me create another dedicated directory for this demo. Let's say I'm going to create a VPC for Flipkart customer. Just an example. So create a dedicated directory, Flipkart demo. So in this directory, I'm going to create a set of basic files, vpc.tf. So in this single file itself, I will provide the basic resources like providers, variables and all. Already we have covered all these things. So I'm not going to create a dedicated file for each things. So provider already I have copied and mentioned here. Also I have copied the module and pasted over here. So in a single file we have specified everything. Now I will change these parameters based on my requirement. Source already defined correctly. So here name, let me change the name. Here I will use Flipkart VPC so that the name of the VPC will be Flipkart VPC. And CID range, it is anyway same. Availability zone, you can choose anything you want. We have 3 zones. If you want to use 2, you can use 2 or you can update more. I will use only 2. Okay, so I use 2 availability zone, also 2 private subnets and 2 public subnets. Already default range has been provided. If you want to customize anything, then change it accordingly. So in our previous example, while creating the AWS VPC using individual Terraform resources, we have created only 1 public subnet and 1 private subnet. Since we are using modules, I am going to create 2 public subnet and 2 private subnet. So do you want NAT gateway? No. So I will use false or just remove this line. By default, it will be false. Similarly, I don't want VPN gateway, so let me remove it. This is how we customized and we add parameters or remove the existing parameters based on our requirement. And tags, let it be the same. Tags, okay. So in the module, there is a name, VPC. So let me change that into VPC1. Here, in the name, I will use Flipkart VPC Dev. So the concept is this particular VPC will be created like Flipkart VPC Dev. So also we will create one more VPC so quickly using these Terraform modules. That is why I create an environment like dev. Also I will create prod. Let's apply these changes. In case of any issues, we'll troubleshoot it. Let me switch over into the newly created directory Flipkart demo. Since it is a new directory, it is not initialized yet. I will initiate the Terraform using Terraform init. Here if you see, this time it is downloading the modules, not resources. So anyway, it will download the latest version. If you want to customize the version, then you can specify the version parameters if that particular module supports. So it is initialized. Before applying, see how this directory is created. Under .terraform, see modules directory is created, and if you expanded it, VPC1 directory is created. That is because in the module we have mentioned VPC1. So it will create a dedicated directory for the particular module and it will keep the associated or necessary resources inside this module directory. You see lot of Terraform files like how we create the resources individually. Similarly, the developers have created all these files for you. Even if you click on this main.tfc, all the codes in high level already the developers have specified in this file. Okay. Let's apply the change. If you want to plan before applying, go for it. Since it is a demo, I will directly apply this with auto approve. So hit enter. It started creating the resources. Okay, now we see some error. This is related to the availability zone. If you see this error, the error is very clear that the subnet can currently only be created in the following availability zone, that is US East 1A, 1B, 1C, those things. In the region I have mentioned US East 1, but in the availability zone I have used EU. Since I have copied from the default example, the availability zone was mentioned like this. But in our provider I have used US East 1. So I want to create my VPC in US East 1 region, so I will update it accordingly. Then again we will apply it. So apply is going on. By meantime, I will go to my VPC and refresh the page. Here we have two existing VPC. So once I refresh, I see the newly created VPC, that is Flipkart VPC Dev. Even all the resources are created. So now we'll do a basic check, like since we have used Terraform codes to create the AWS VPC infrastructure, we need to verify all the resources are created properly or not. Even we have not specified to create internet gateway. So we need to see whether the internet gateway is created and associated to the public subnet or not. Those basic checks we need to do it. So VPC is created along with the CIDR we have mentioned. Now go to subnet and refresh the page. Now if you see, these are the subnets associated for the Flipkart VPC Dev. So 4 subnet it is created because 2 private subnet and 2 public subnet we have provided. So accordingly it is created on each availability zone. If you see the public subnet range 101 and public subnet range is 102. This is how we have defined it. For private we have defined 1 and 2. See, private it is 1 and the second one is 2. Let me confirm the internet gateway on the public subnet. See the route table, internet gateway is attached. So ID is end with B1. Similarly, I will go to the second subnet and see internet gateway B1 is attached. So if you see the private subnet, internet gateway is not attached. That is how the developers developed the modules. See, by using this simple 10 lines of code, we have created the entire VPC architecture. Let me simply deploy EC2 on this VPC to test it. In order to create EC2 resource, then we would need a security group so that we can access the server. But if you see the security group, this module have created already a security group by default. If you see the inbound, there is no entry and there is no entry for outbound as well, because this particular default security group being created by the module itself. If you want to use this security group, yes, you can use it, or you can create your own using the individual Terraform resources. So what I will do, I will refer the previous vpc.tf where we have created all these resources individually. I will just copy the particular security group resource section and I will paste it here, and I will update the resource section based on this new VPC. So this is SG SG1. Okay, name. So in the previous section already we have referred the variables and all. Since I have copied from the previous file, so already we have covered the variable topics in the previous sessions. Okay, just I copy the name and I will paste here. So this security group will be created like Flipkart-VPC-SG1. So even for attaching the VPC ID, already the interpolation is defined here. Since we have copied from the previous session, that is referred to the Terraform resources. But this time we have used modules instead of resources. So here I will change this VPC ID module.vpc1, then search for related to ID. But still VPC underscore ID. But I will tell you how did I use this interpolation call. Already we have applied the Terraform. So if you see the Terraform state, scroll down and search for ID. Module AWS VPC section. Here this is the ID of VPC ID. Module.vpc1.id, because that is how that hierarchy is mentioned. Anyway, the increase is already defined. And anyway, in inbound, the AT is allowed, so that in case of I install Apache, I can access through AT port from anywhere. That is why that ingress is allowed. Egress is nothing but the outbound. In tags also, it is defined like variables. So I will copy this name. I will change it. Okay, now we'll apply it again. Now there is an error. Let's see why. The error is for the ID what we have mentioned, module.vpc1. Okay, the object doesn't have an attribute named ID. If I search in the Terraform state file like vpc underscore, the name is vpc underscore ID. Let's apply it again. So now the security group is creating. Okay, that is completed. But Flipkart-SG1 is the one we have created now using the Terraform Resources integer. Just click on this and see the inbound and outbound. It is all created like how we have added in the code. Now we'll deploy EC2. For EC2 also, I will refer my previous file, copy the resource section and paste it over here. It is already commanded, so let me uncommand it. Control KU. Now we can update the values based on our requirement. Let it be the instance name is web1 and AMA also let it be the same. Instance type is called from the variable. I will use a value like T2 micro directly. Subnet ID. So we need to deploy this EC2 in one subnet. If you deploy the instance in the public subnet, then only we can access it, because internet gateway is attached, right? So I need to give the correct path using the interpolation model, how we have defined the VPC ID in the security group. Similarly, we need to find the subnet ID of the public subnet, then we have to define it over here. So again, module.vpc1. Now we need to find the respective ID. So search for public something like this. See, if I give this subnets, the public subnet itself, it has two subnets. So now we don't know on which subnet it will be created, because we have a two public subnet. We'll keep this value. Let's run this. If we have any issues, then we'll update it accordingly. Key name, let it be demo v1. And public IP address, yes, we need it, then only we can access it. VPC security group, we need to define the security group over here. So already we have created the security group using this resource. So we need to use the ID. Anyway, this ID is same because already we have copied from the previous section, right? Output section, you need to print the IP of your instance, then you can use this output section. Okay, let me uncommand it so that the IP will be displayed. Let's apply this first. If we encounter any issues, then we'll troubleshoot it. Okay, now if you see, as we expected, we got an error. I told you, right, the public subnet, it has a two public subnet. That is why it is mentioned like public subnet is a tuple with two elements. If we have a 5 subnets, then obviously it will show you that the tuple with 5 elements. So we need to specify on which subnet we have to deploy the EC2. In the programming language, okay, this is a list or tuple. The starting value in programming language will be 0, 1, 2, 3 like this. Okay. The first value will be 0, then 1, then 2, like this it will go. Since it is concept of programming, if I want to deploy the EC2 on this particular subnet, then I have to use 0 with square bracket. Again, we will apply it. Meantime, we can go to EC2 instance and refresh the page. And see, by the time it is created, web1 is created and it is in initializing state. Now select this instance and see whether the EC2 is properly used the correct security group, also whether it is deployed to the correct public subnet and VPC. So go to security group and see Flipkart VPC SG1. This is correctly associated. Now we'll go to networking and see the public subnet correctly associated or not. Also verify the VPC ID. So it is correctly deployed in VPC dev. Also the subnet ID is deployed as we mentioned in the public subnet. So 101 is a range I have given. Now I will verify the IP allocated to that EC2 instance. If I get 101 range, then the EC2 is correctly deployed on the public subnet 1 I have referred. See the private IP, it is 101. Even we have already used output section. That is why it is displaying the IP. Okay, let me open putty. Let's see we can access the instance or not. These are basics of accessing EC2 instance. I will use the keys. Since we use Ubuntu, I will use the username Ubuntu. Yes, I am able to log in to the EC2 that is deployed on the public subnet. Let me log out from this session. Okay, now if you see, by using the Terraform modules, we have created a complete VPC architecture. Okay, now we have created one VPC for a client Flipkart and the environment is dev. Now if I want to create another VPC for a dedicated environment, simply replicate this. This is how we can create the VPC so faster. In the last, I will paste it again. Instead of VPC 1, I will change this to VPC 2. So it should be a unique ID. And in the name, I will mention as prod. You can change further options as you want. Let me apply it. Okay, now if you see, I got an error like the module is not initialized because it has to download the module dedicatedly for the another VPC. So now if I do a initialize, it is clearly created a VPC2 directory dedicatedly for the modules. So this is why we are reusing the modules. Again I will apply it. Now go back to VPC and refresh the page. Now if you see, we have two VPC for Flipkart, dev and prod. Even if you go to subnet, obviously the associated resources will be created so faster. See the prefix of this. These are dev and associate public subnet and private subnet. And here if you see, these are prod and associate subnets. So the Terraform modules or reusable units, also it simplifies our code. Only if you have Terraform modules for your task, then you can use it. If you don't have the modules for your task, then obviously we have to go for Terraform Resources. I am using Visual Studio Code for working with Terraform resource files. I have created and used a few directories already. For this topic, I have created a new directory called tfproject2. I have added a provider file and specified the region as US East 1. So I will be using a single file here called ec2.tf where I will be adding all my resources and will go through one by one. So all these basics are already covered in the previous topics. What is Terraform conditions and why do we use it? So when you want to set some values based on some conditions, there we will be using Terraform conditionals. This is like a if-else conditions in any programming language. Like if the condition is true, then some task will be performed. If the condition is not true, then the other condition will be performed. Similarly, in Terraform, conditionals also help us to set a value based on a condition. The format is condition true value false value. So if the condition is true, it will pick the first value, what you have mentioned here. If the condition is false, then it will pick the second value after the colon. This logic can be applied wherever you want to set a value based on condition. Here, I have a variable section as well as a resource section that we will be using to create a EC2 instance. So here we have defined the resource section. So this resource will be creating a AWS EC2 instance. So AWS instance is the resource name and web1 is the instance ID. Also I have specified all the basic parameters like AMI, instance type, subnet ID, key name, and EBS volume size, associate public IP address, security groups, and tags. Here, if you see this instance type, I have referred my variable called environment. So the value what is mentioned in the variable environment will be set here for the instance type. Here the value would be dev. Generally, we will specify the values directly like type of instance, T2 micro, T3 medium, or X5 large, something like that. Even in tags, I have referred my variable environment. So the default value is dev. So dev will be set in this tag. Okay, let's see how we can implement this condition like a real-time example. This resource section is for one instance. By assuming this resource section itself, we know that this is going to be create a single instance and for dev environment, because on the tags we have mentioned to set the name like environment and the value would be dev, which means this instance is dedicatedly creating for the dev environment. Let's say we want to create multiple EC2 instances for different environments. On that case, what we will do, we will just copy this resource section and duplicate it, and accordingly we need to update the values based on the requirement. Let's say I'm going to create this resource for production environment. So I need to change the instance name to something else. I cannot have same ID. So I will change this to web2. Let's have the same AMI. Okay, in instance type, let's say since it is a production, we will use some heavy instance type. For example, X5 large or something else. For example, let me use T3 medium. So subnet ID, if you have a different subnet, then you can change the value accordingly, and key name can be same. And if you want to increase the EBS volume from 10 to 50 GB or 100 GB, then you can change it accordingly. Okay, so if you see, I have a two resource section. One is for dev environment and other one is for production environment. So in this case, we need to think logically that I need to simplify my code because the resource section is common, but only thing is there are few values or different for the production environment. So here we need to think smartly and we need to consider whether we can implement the conditions here or not. Okay, let's apply the condition here. This is a dev environment. Then the instance type should be T2 micro. If it is a prod environment, the instance should be T3.medium. So let me remove this value. First, we'll call the variable environment, because the condition should be like if the environment variable is prod, I need to set a value. If not, I need to set a different value. So here the condition is var.environment equal to, which is double equal to, and within double quote I need to specify the value. If it is a prod, then I need to set a T3.medium. If it is other environment, it's not only dev, if it is a QA or if it is a UAT, I can go for a low instance type. So I will start my condition with production. Okay. So where dot environment equal to prod, then I will give you the true value. Okay, which is T3 medium. Then colon, if the environment is not prod, then what instance type I should give? It is T2 dot micro. So if I set my environment as a prod, then the instance type would be T3 dot medium. If anything else, then the instance will be T2 dot micro. So you can apply this logic wherever it is possible to apply it. Let's save the file and apply the configuration. I am already inside the directory and already have initialized my Terraform. So I just run Terraform apply. If I do Terraform apply, at the moment the variable environment value is dev. So if I do apply, the instance will be created like T2.micro because the condition is false. So instance is created now. Now go to your EC2 console and refresh the page. The web server 1 is created already and the instance type is T2.micro. We have not passed any argument for variable. We simply apply the configuration with the default value. Let's say I want to create an instance for production. So we have already a condition logic in place. So you can override the environment variables in two ways. Either you can modify the default value in your Terraform file, or directly from the command line we can use the -var flag. So -var within double quote environment equal to prod. So if I go with this -var flag, the environment value in the default will be overwritten with the current value I given in the command line. If I run this, the condition will become true because the environment is equal to prod. Then obviously the Terraform will pick the first value, that is T3.medium. Already we have launched an instance with this resource. So let me destroy it first with auto approve. So it won't prompt me for to enter yes or no. Again refresh the EC2 console. So instance is terminated now. So now again we'll apply the Terraform along with -var flag. So it is applied. Refresh the EC2 console again. Now if you see the another new instance is created, now the instance type is T3 medium. That is because our condition is true. Based on the condition, it has taken the correct value. So this is what the conditionals in Terraform. So you need to think smartly and apply the logic if possible. Using these kind of features, we can simplify our code better. If you want to know more about the Terraform conditional, then search it in the search engine, and here you will have the HashiCorp official website link. You can go through all these things. Then we'll talk about loops. Loops are used when you want to create multiple resources of same type. So instead of copy pasting the same block many times, we can use loops smartly to simplify and scale it. For example, let's say you want to create 10 S3 buckets. So we will be using the same resource section and we will duplicate it 10 times. Similarly, if you want to create 10 EC2 resources, then you will copy and paste the resource section 10 times and you will update the values accordingly. Since you have the same type and resource section, then we need to think whether we can apply the logic of loops or not. So in Terraform loops can be achieved in two ways. One is count and for each. Count generally based on the numbers. Let's say 10 or 8. If I say 8, the loop will be executed continuously for 8 times. As we give 8, in the programming language, the value will be starts from 0, which means 0. The next loop it will be 1, on the next loop it will be 2, it will keep on go till 7. So obviously we will have 8 numbers here, but in the programming language it will start from 0, which is the index. We call it as an index. Okay, so index starts from 0 till 7, that is why it is a 8. If I say it is 2, then I will have the index values like 0, 1. If I give 3, then 0, 1, 2. Then for each will allow us to give the values, not like the numbers. Okay, for example, in a list we need to specify the values like web 1, web 2, web 3. If I want to create a 3 EC2 instance, if I want to create a users, then I can specify the usernames in a list with comma. So again, for each time one value will be picked and the resource section will be executed. Then again the loop will continue and it will take the second value, then again it will execute the task. Okay, let me remove this. Let's use the same example of creating the EC2 instance. Let's assume like for 10 EC2 resource instance or 3. As this is a demo, we can go with the small numbers. Okay, let me create one more variable to specify my values, like EC2 underscore names. And here in this value, within the list, I will define the values like web1, web2 or anything else, db1 and app1. So 3 servers. So this is what I am going to do. For dev environment, I will create 3 instances. It's like a 3-tier architecture, because in an environment we will have web servers, application servers, database servers. So for dev environment, I am going to create 3 instances. If you want to create different names, obviously you can go with that, like web1, web2, web3 or anything else. Now, in the resource section, this is the same resource section what we have used for general EC2 creations, right? If you want to implement a loops, then we need to add just what kind of loop. So I will go with the for each first. So for each, if I give this for each itself, then Terraform will understand that we are going to perform something in a loop. So for each, now we need to bring the values here. To bring the values from the variables, we need to define to set the values. Okay, to set within the bracket. Now we can call the variables var.ec2 underscore names. So var.ec2 underscore names is a variable. It has a 3 values now. It will pick the values one by one. During the first loop, it will take the first value. On the second loop, it will take the second value. So once this is done, then all other options can be same, and the instance type already we have implemented the conditions. Let it be the same, because we are going to create the environment for dev. But anyway, the condition will be false. So my instance will be t2.micro. So let it be the same. In tags, we have already used var.environment. So the name will be dev. Let's apply this. Before applying, let me destroy the existing instance. It's destroyed. Now we'll apply the configuration. This time we don't want to override the environment. A resource is created. Now if you go to your EC2 console and refresh the page, you can see 3 instances, 3 servers. All instances are T2 micro. And if you go to tags, the environment is dev. But here if you see the server names, it's all web server 1 because we have not changed the server name in the code. It is supposed to be web 1, app 1, db1, right? Okay, now what we can do is, again we can apply the logic. Already we have implemented the for each. So values are already in the for each parameter. So now we need to use the same type. The value is already set to for each. So now we need to call the value here for each value. Okay. So I will remove the string and instead I will just add each dot value. Let's apply this. Now refresh your page. Now if you see, the server names are changed based on the values. So for this dev environment scenario, we have got our 3 servers for our 3-tier architecture. Let me destroy it again. Now we will see count loop. So count is based on the numerical value. Instead of for each, I will just put count and equal to the value. Let's say 2. But here in the tags already we have implemented for each concept. So that is why we have defined this value. So we cannot use this one because we use count loop now. Since we use count with the numbers, what I will do within this double quote $count dot index. It is not a count because count dot index. Now the index will be 0. So what I will do to make it easy to understand, I will add the prefix like dev hyphen. So my names will be dev hyphen 0, dev hyphen 1. It will be much better. Let's apply this. Refresh the page again. Now if you see the servers dev 0, dev 1. So we have given only the 2 EC2 instances to be created on the count. That is why we had 2 EC2 instances. Finally, built-in functions. Terraform has lot of functions that will help us to transform or manage our values. This is like a programming related things only because it will have a string functions, numeric functions, collections, mappings, datetime functions, lot of things are there. We are not going to use all the things, but if we need it, then we need to find the respective function and we can implement it. If you search in the search engine like Terraform functions, so here is the link, functions. Here you can see all the functions. On the numeric function itself, you have this much of functions. Whatever you need it, you can use it. Lower, upper. Let's try to use one function on the same example. Here if you see the instance name, it's all in smaller case. dev hyphen. Let's say we want to change the value into upper cases. For that, we can use a function called upper. So the names are dev-0, dev1. But before that, if you see our instance, it starts from dev0, dev1. It would be good if that starts from 1, 2, 3 like that. Okay. So on that also we can apply a logic like I can add plus 1. If my index is 0, then it will add 1. So my EC2 name will be dev1. Similarly, for the next time, if the value is 1, then the EC2 name will be 2. Again, apply the configuration. And refresh the page. Now if you see, the names got changed. It starts from 1, 2. Okay, coming back to built-in functions, I'm going to change my server names to uppercases. Generally, the function should be in this format, like function name, and within the bracket we can define these values. Already we have this value, just cut the value and we can use a function. Already it is lower, so I will change this to upper. Within the bracket I will use a value. Remove these unwanted lines. So upper is a function. So again apply the configuration. Refresh the page. The names got changed into uppercase. This is how we use the functions. We need to find the respective functions and we can implement it in our code. Terraform underscore project 2. This is the directory I am going to use it. Here I have a provider.tf where I have mentioned my provider, that is AWS, and the region is US East 1. And in the main.tf I have a resource section and I have mentioned all the basic parameters that is required to create a AWS EC2 instance. This directory is already initialized but not applied. First of all, what is Terraform state file? Already you might have seen this Terraform state file in my previous videos. The Terraform state file will be created only when we have applied the Terraform configurations. So Terraform actually build your infrastructure and then it will write down what it is created. So it will keep tracking of those resources which are created through Terraform, about what resources it has created and its IDs and all other metadata. All these kind of data will be saved in a file called terraform.tf state file. Think of like it is a Terraform memory or it is a blueprint of your target infrastructure. So here is my resource section. Okay, let's take this as an example of we creating an AWS EC2 instance. Terraform apply. I will use auto approve to apply my configuration. If you want, you can use Terraform plan and you can go for Terraform apply. Since this is a demo, I will directly go for apply with auto approve. Okay, the Terraform configuration is applied. Refresh your EC2 instance page. You can see the server is created, that is web1, and this is the ID, and the instance type is T2 micro and tags web1. Okay, since this is applied, now we have a terraform.tf state file. So by default, Terraform saves the state file right in your project folder, that is TF project 2 here. It is just a normal file. So you might be wondering, why does Terraform need to remember anything? Let's say we have created an EC2 instance on AWS. Since we have applied this configuration, we have got this TF state file. Let's say we need to change the instance type in our code and apply the configuration. What if Terraform doesn't have this memory? Terraform will think that we are going to create an instance newly. So without that state file, Terraform has no idea that the instance already exists, so it should not create new one. It should update the values. This can be achieved only if the Terraform has such configurations in memory. So this is why the Terraform has all these informations. Since this is a normal file, you can open with your editor, but it is not recommended. Just for your understanding, if you open this file, this is a JSON structure file. So we should not edit this because it could break your infrastructure. We have a set of commands to manage our state. Okay, we'll cover the topic later. First, we'll understand all about the TF state file. Okay, so this Terraform, we have applied this configuration only once. Okay, now I will change some of the values. For example, let me change this to 2. So my host name of AWS EC2 will be changed to web2. Okay, so let me apply this change. Since we have the state file in the memory, so Terraform will go and check the Terraform state file also on the target infrastructure. Terraform will come to a conclusion that already this resource is managed through Terraform, so we should not create new one. Instead, that will update the values. So this is the importance of TF state file. Okay, again we have applied it with a small change. Just go to EC2 and refresh the page to make sure the change is reflected or not. So here, if you see, we have only one instance and the name is changed to web2. This is the change we have done. Okay. For example, if I don't have this TF state file and if I do apply, obviously the Terraform create a new instance again with the same web2. This is the issue. Okay, so be careful with that. So we would need a Terraform state file to track all the resources which is managed through Terraform. This is like a memory or blueprint of your target infrastructure. Alright, now earlier we had TF state file. Now we have TF state.backup. This is because TF state file will have the information about the last applied configuration. The TF state backup is a previous apply. Okay, which means if you open this TF state and check for web2, my tags being changed, and that information only this recent TF state file has it. That is a change I have applied recently. So that information only stored in this TF state file, that is a current state file. Okay, what about the backup? I said it is a previous applied state file. Okay, if you search for web2 here, we don't have it. Okay, by the time the tag was web1. See, so the TF state is the current state what you have applied recently, and TF state.backup will have the previous applied configurations. Clear? Okay, now since this is a file and JSON structure format, we should not do anything directly with this editors. Instead, we have to use state commands. Okay, so Terraform show. This is the first command I wanted to show you, that Terraform show you all the information that Terraform state file has. Okay, here if you see, all the information about the resources being managed through Terraform will be shown here. So the resource ID is like AWS instance.web1. So that is a ID we have used in the resource definition. Followed by that, you will have all the meta information about the resources. Okay, now this is Terraform show. Now Terraform state, here we will do state list. So this will give you in short the list of resources are managed through your Terraform. So far we are managing only one resources, that is AWS instance, and the ID is web1. Okay, so web1 is not your server name or anything. This is a Terraform state ID. If you have multiple resources, accordingly it will list all the IDs. Assume that you have hundreds of resources being managed through a Terraform. If you want to show information from a specific resources, then again we can use state show and the instance ID. This will show the information of a specific resources. Here we have an interesting other commands like Terraform state move. This command is like telling Terraform that we are going to change some ID in our code, but still it is the same resources, but unfortunately we have to change the resource ID. Let me tell you an example. Okay, let's say I have this resource and here the resource ID is web1, but my host name is web2. In future it will be confusing, so I have to change this ID to web2. Then only it will look easier to understand. Okay, so web2 resource ID belongs to web2 server, correct? Okay, let me revert back it again. My host name is web2, but my resource name is web1. Either you need to change your host name back to web1. If I do web1, this is a simple change. I don't want to inform Terraform. I can simply directly apply the configuration. My EC2 name will be changed. If you are changing this to web2, then that is a problem. Reason? If you see Terraform state list, your Terraform has the information about AWS instance.web1. Now your resource configuration has information about web2. When you do apply, Terraform will go and check, do we have web2 informations in the Terraform state file? But it will not there, so it will create a new resources. But still, you are using the same resource. So that is why we need to inform the Terraform that I am using the same resources for my same purpose, but I need to change my ID. This is why we use Terraform state move command. So Terraform state move, change your ID but don't apply it without renaming the state. Okay, so in order to rename that ID from web1 to web2, we need to use the command Terraform state move space copy the ID and the new ID web1 to web2. Enter. Now successfully it is moved web1 to web2. Now if you do state list, the ID got changed in the Terraform memory like web2. Now if you do apply, this will not create a new resources. Instead, it will apply the configuration if you have any changes. Let me apply this. You should not change the ID without knowing the impact. If you want to change any ID that is already applied and Terraform has the information about the resource, then you should not apply it directly. You should rename the state, then you can do a apply. Very rarely we use this command on such scenarios. Now if you go to resource EC2 and see it is not created newly. Okay, now another command, that is Terraform state rm. Rm means remove. So we are going to remove some resources from this Terraform state file, which means from Terraform memory. So if you have the instance or any other resources on the target infrastructure, Terraform will not manage it anymore through your Terraform configurations. So we are just removing the state, removing the resources from only the state file, not from your target infrastructure. When there is a condition like you want to keep the resources on the target infrastructure, you wanted to bring out the resource from the Terraform knowledge, on that case you can do Terraform state remove. What if I remove this section and do apply? Terraform will check this ID in the Terraform state file that holds this information about the resource. Then this will delete the resources on the target infrastructure. Okay. Only if you have that condition, then do it. But my condition is I don't want to remove the resources on the target infrastructure. Just I need to bring out the resource from the Terraform knowledge. That is why I remove the resources from the state. Terraform state RM, and which resources I need to remove. I need to specify the instance ID. Here instance.web2. See, it is removed from the Terraform state file. Even if you do apply now, so it is just removed from the state file, but it is not removed from my target infrastructure. Okay, but still I was having that resource section in my configuration. That is why when I do apply, it is assuming that it is a new resource, that is web2, because that ID is not there in the TF state file because we have removed it. That is why it is assuming and recreating the resources. Once you have removed the resource from the state file, and you can remove your section as well. By then, it will not do anything on the target infrastructure. Okay, now if you go and check your EC2 page, see, now we have two resource instances. One was the old one, the other one is created newly. Okay, let me destroy all. Okay, only this resource is managed through Terraform, not the old one, because we have removed that resources from the Terraform state file. That is why it is not managed through Terraform now. So I will delete it manually. Okay, now we'll talk about the important topic, that is how do we manage this Terraform state file in remote. Why? Because as of now the Terraform state file is residing on my local laptop in the current directory. As I am only managing this configuration, that is fine. But still, what if this laptop crashed or something else? So I must have a backup. On that case, you can take a backup of this TF state file somewhere, or you can use it on Git repository, or else we can manage through remote backend. So the TF state file will not be managed in any local directory. It will be on the remote backend. There are many remote backend being supported. As of now, since we are using the AWS, we can use S3 as a remote backend. So we can keep this TF state file in a S3 bucket. From there, Terraform will automatically pick the TF state file and manage it. Okay. You can create a new file called remote.tf or backend.tf, or even you can create the section for remote backend on your any of your Terraform resource file. I will create a dedicated file for handling my backend. So I will say backend.tf. Here you can start with Terraform. Since I use Visual Studio Code Editor, it gives me the options. Okay, Terraform and open braces and closing braces. Within that, I need to use backend, hit enter. Now in this code, I can use all these options. So we need to find based on our target infrastructure. Here we are using S3, so I will go with S3. If you have something else on Azure, then you can go for it. Similarly, we will have all these remote backends. So I will use S3. Now here we need to use our bucket name. If you are not sure about these section examples, so go to your search engine and search for Terraform remote backend S3, and this is the official website of Terraform. Just click on this, and here you can get your example. So already I have used this. Okay, let me remove and paste here. Okay, here on this bucket, I must have some S3 bucket on my target infrastructure. So already I have an S3 bucket. Called skumar0710. You can create based on your requirement in any names, client names or environment names. Here I will just copy this bucket name and paste it in my bucket. Okay, so key is nothing else, the path and Terraform state file name. Okay, so here if you see my path, I have a folder called files. You can create a new folder, you can use it, or I will use here like demo / and file name. You can use any file name. Okay, now the region is US East 1. Obviously, this is my region as well. Okay, this is how we set the remote backend. So this will store the state file in an S3 bucket. So we don't want to use the Terraform state file locally. Instead, we can use remote backend. So let me apply this configuration again. Okay, since we use a new resource from the Terraform itself as a backend S3, Terraform has to download the particular modules. Okay, that is why we got an error like backend initializing required. So let me rerun Terraform init. Okay, now do apply. So we have this resource for EC2. Okay, it is applied. Now go back to EC2 just to make sure the changes are applied. Okay, now we got the new server. Okay, now I will go to S3 and refresh it. See, we got the directory called demo. Get into the directory and see Terraform's TF state file is stored in the S3 bucket as a remote backend. Now, how do you make sure that this TF state is only being used by Terraform? If you see the current Terraform state file in your local directory, it doesn't have any information about the resources. So let me use Terraform state list. So this will list all the resources being managed by your Terraform, right? So here it shows Web2. But in state file, it doesn't have any informations. So obviously, now you understand that this Terraform is using the Terraform state file as a memory from your remote backend that we have configured on S3. Even if I delete all these Terraform state files, I will not have any issue. Again, I run Terraform state list. Still, I will get the list of the resources managed through Terraform. Even if I do apply, I will not have an issue. See, it is refreshing the state even if you don't have a TF state file, which means it has the information in the Terraform state file. Usually, when we manage different environment, we will create a separate Git branches in a repository like dev branch, QA, prod and all. Or we'll create a separate directories like this. So dev environment will have all the Terraform resource files. Prod environment, I will have similar Terraform resource files. Similarly, for other environments, I will copy the same resource file and keep it in a different directory. This is how we generally manage the multiple environments. So each directory for each environment will have these resource files. For example, in this dev directory, which is managing my dev environment. So here if you see this main.tf, I have a resource section which is nothing but on dev environment will create a EC2 server. So same code, same directory, I will copy to create another environment. Let's say I want to have a different environment for prod. Then I will copy this directory and rename the directory to prod, and I will make the changes accordingly. So here in this prod directory as well, I have a main.tf, which also having the same code. So similarly, if you want to manage multiple environments, this is what we do. So here is the actual problem. If I want to make a small change, like in dev environment, I want my instance to be T2 micro. I want all my environments, resource type should be same. So in this case, if I want to use T2.micro or T3.medium, I need to go and update each main.tf file in every directory, update the value, and I need to apply it. But if you want to manage these environments smartly, like I can use the same resource file and apply it for different environment. This is exactly where Terraform Workspace come in and make our life easier. So Workspace in Terraform is like an isolated environment that will have own state file, but it will share the same code base. If you see this diagram, the Terraform code base will be same, but for each environment, we will create a workspace. Each workspace will have a dedicated state file for that particular workspace. Here, we can consider this as an environment. This is the beauty of using Terraform Workspace. So think of it like we want to create and manage multiple environments like dev, prod, QA. Instead of creating these kind of different directories and copy paste the same code, I have created a single directory called workspace-demo. And I have copied the same code here only once. Okay, now we'll see how to create workspaces and how to switch different workspaces and how to apply it. Okay, so this is the directory I'm going to use it now. Let me first initialize. Even if you have not created any workspace, by default, Terraform has created workspace called default. So Terraform Workspace show. Here, by default, Terraform has created a default workspace for you. So this is the one you have been using even if you don't know it. So let's create a new workspace for our environments. So how can we create it? Terraform Workspace new, then the environment name. For example, dev. If you are not sure about these commands, you can get help. Terraform Workspace --help. So this will give you the list of options available related to Terraform Workspace command. Okay. Terraform Workspace new, then the environment name. Here first we'll create dev, which is nothing but we are creating a workspace for the dev environment. So it is created. Once this is created, this will be switched into the created workspace. So how do you confirm it? Terraform Workspace show. Now you are in dev. Similarly, we'll create another workspace, prod. Now you are switched into prod. Again, I will create one more, QA. So if I run this Terraform Workspace show, this will show me the workspace I am in. Okay. If you want to get list of workspaces available in your current directory, I can give list. So we have this much and I am into QA now. Now if I want to switch over between any workspaces, I can use Terraform Workspace select. I can switch to any workspaces I want. For example, if I want to get into dev, I can use the workspace name. Now I have switched into dev workspace. You can use list or show, that will give you the information. So this is how we switch between workspaces. Let's see how we apply the configuration for each workspaces. Okay. Now I have a similar Terraform configuration, like I have a provider where I have mentioned my provider is AWS and region is US East 1. Also I have a Terraform resource configuration file main.tf. Here I have defined my resource to create EC2. You can create multiple resources as you want. Okay, for this demo, I will be using this one resource. Let's say if I apply this configuration from dev, the server will be created in the name like server 1. This is what we generally do from the default workspace. But smartly what we can do is dynamically we can update the value, like how we used variables. Similarly, we can use the Terraform workspace dynamically. For example, here in the prefix or suffix, you can define like dollar. Within the curling braces, I can use Terraform dot workspace. So this is my code. So my server name will be created like server1-dev. If you want, you can put it in the prefix. It's up to you. Okay. Let's apply this configuration. So right now I am in dev. So Terraform apply -auto apply. Okay, the configuration is applied now and we are in dev workspace. So this configuration is applied for dev environment. So let me go to my EC2 and refresh my page. So my server 1-dev is created. So we can think like this resources dedicatedly we have created for dev environment. Similarly, you can create multiple resources. Okay, as we have only one single resource, this is fine. Now, if I want to make the same code into multiple workspace, I need to switch over into that particular workspace. I can apply it. The point is, I'm using the same Terraform code for multiple environment. Select. I will go with QA now. Now again apply it. So the configuration is applied. Again I will switch over to prod environment. Again I will apply it. Okay, now if you take this example, we used same Terraform resource files. So I have created multiple workspaces to manage my different environment. So I switched over to each workspace and applied the same configuration. If you go to EC2 and refresh the page, now you see server 1 dev, server QA, server 1 prod. So you have servers for each environment. So the same code is used, but the resource gets created independently in each environment. How it is maintaining its state file for each workspaces? Because we need a state file. But if you see here, we don't see that TF state file. Instead, Terraform has created a directory called terraform.tfstate.d. If you expand this, you can see created a directory for each workspace and it has saved the file within the directory. So it is maintaining the TF state file dedicatedly for each workspace. Okay, one more thing, we can dynamically update the values based on the environment need. For example, for lower environment, I can use a small instance type. For production environment, I can go with little higher instance type. So how can we achieve this? Because we use a single resources. On that scenario, we can use conditions. So this topic is already covered in the condition topic. Go through it. Okay. So what I can do on instance type, how we generally use the different condition, some var dot instance type equal to, if it is prod, then I need to define the first value. For example, t3.medium. If the condition is false, Terraform can pick up the second value. I will go with t2 micro. So this is how we generally define the conditions. So this is the condition and it is the value of the condition. If this is true, then it will pick the first value. If it is false, then it will pick up the second value. So here, what we have to do is, we have to refer the workspace. Terraform.workspace. If the Terraform workspace value is prod, then my instance type will be t3.medium. If it is not, then it will use t2.micro as an instance type. So let me start from workspace, select dev. Now apply the configuration. Here the condition is false. The workspace is dev. So the condition is false. That is why T2 micro will be set. It is already set, so that is why it is refreshing. Now I will switch over to QA and I will apply the configuration. Okay, now I will switch over to prod, then apply the configuration. This time the condition will become true. Terraform Workspace will be prod, so it will pick T3.medium as the type. Initially the instance type was T2 micro, so now the change is there, so it will apply the new change. So that is why we see this modifying. So the configuration is applied in all workspace. So let's go and refresh the EC2 page. So here if you see dev and QA, the instance type is T2 micro, but for production it is T3.medium. So Terraform Workspace helps us to manage multiple environments using same set of code. So each workspace has its own isolated state file. So we can dynamically use the workspace name to change tags, names, instance types and other parameters. Okay, let's say we want to delete a workspace. So you can simply run Terraform Workspace delete the name of the workspace. But the condition here is, if you are already in the workspace, you cannot delete it because it is an active workspace. So let me switch over to workspace, select QA. From here I will delete prod workspace. This is what I want to show you. If you are planning to delete a workspace, first thing you need to delete all the resources. How would we delete all resources? Destroy. So only if you do a destroy and make it clean, then only you will be able to delete a workspace. So first I will destroy all the resources, then I will delete the workspace. As we have only one resources, it is deleting the one resource. If you have a multiple resource, accordingly it will destroy it. So now I will switch over to default. From here I can delete all the workspaces. First I need to switch over to another workspace. From here I will destroy the resources. Then we'll use prod. Again we'll destroy it. Now we'll switch over to dev. Destroy the resources. Okay. Terraform Workspace list. From here I will switch over to select dev. Sorry, I have to get into default. From here I will delete the workspace one by one. So this is how I need to delete it. Terraform Workspace delete the workspace name. I will start with dev, then QA, then prod. Now we don't have any workspaces. This is how we use Terraform Workspace delete command. What are Terraform Provisioners? Provisioners are like a post setup scripts. So this will help you to perform some extra task once the Terraform has applied the configuration. Like you can copy your file, you can do installation, you can configure your services, you can run any scripts. Here we have a few types of provisioners: file, local execute and remote execute, in which we will primarily focus on file type and remote execute type. That is because since we are using Terraform for infrastructure provisioning, once the resource is created, we need to set up everything on remote. So we need to use only file provisioners or remote execute provisioners. Let's first understand the file provisioner. As the name says, it is a file provisioner, which means from your local machine, we copy some files to the remote servers. So the file must exist in your local so that Terraform will help you to copy those files or directories into the remote servers. So in order to copy, we must have some connection type. Either it must be SSH or WinRM. So this type is only used to copy file or directories. Then the another type is remote execute. This particular remote execute provisioner will help you to run commands in your remote servers. By using this, you can achieve some post task like installation, configuration, or any other kind of task. For this kind also, we need a connection type. Here, I have a folder called Workspace Demo where I have a list of Terraform resource files, which is provider.tf, where I have mentioned my provider as AWS and the region is US East 1. Also, I have one Terraform resource file called main.tf, where I have mentioned my EC2 resource section to deploy a EC2 on my target infrastructure. So let's say I have this EC2 resource section. This directory is already initialized but not yet applied. If I run a Terraform apply command, the Terraform will create a EC2 instance for me. But if I want to perform some task like copying files or run some scripts or commands in the target infrastructure, then I need to use the provisioners. On search engine, if you type for Terraform file provisioner, you can click on this link file provisioner. As I said before, this will help you only to copy files from your local system to target infrastructure. Okay. Here if you see this example, they have used the section called provisioner and the type is file. Here you will use only source and destination. Source is nothing but the path and file name in your local system. Destination is the path on your target system. You can copy a file. Also you can copy a directory. Now we have another type, local execute. If you want to perform something on your local system itself, not on the target infrastructure, on that case, we can use this local execute. For example, if you want to create a file, something like text file of your infrastructure IPs, then you can use this kind of provisioners. What IP is allocated for that particular resource that can be written into your local system. Now the remote execute provisioner example is, so provisioner section and the type is remote execute, and within inline section we can use all type of commands. For both the case file and remote execute, we need connection type. So here if you see these provisioners connections, you can see the connection block. Okay. So connection block is nothing but we specify the username and IP address, passwords and type of connection should be mentioned in this connection type so that Terraform will log into that particular instance and will establish the connection for you. Then it can perform the task based on your provisioner type. Here if you see they have mentioned provisioner file type. Within this provisioner section itself they have mentioned the connection type. Here they have mentioned the type of connection. Since it is a Linux machine, we can use SSH. If it is a Windows machine, then we can use WinRM like they have mentioned here. And the user type, root and the respective password, or if we have a key, then we can use the keys. Okay, I'll be using my key and the host IP address over here. Here we can use the interpolation model definition. So here you can find all the parameters that support. Here you can use your private key. Alright. So let's go into our Terraform file. If you want to use this Terraform provisioner, we need to use the connection type as well as the provisioner type. So that should be within your resource section, not outside of your resource block. Okay. So here you can open a new section. First we need to define connection block. Just hit enter. From here you can copy the example from the official website or you can type on your own. So type, by default it has come as I use the Visual Studio Code editor. So yes, I need the SSH type, then user, and I'm not going to use a password. Obviously, since I use a cloud VM, I will go with private key, and here we need to mention to take my SSH key from my local machine. So here you need to use within double quote, you can call your file. Already I have copied my demo v2 perm in this directory, demo v2.pem. So this is the file I'm going to use it. And target host IP. So here we will not aware of the IP unless the resource is created. So we can use the interpolation reference model here, like AWS underscore instance. All these basics are already covered in the previous topics, like how we call the interpolation model. Okay, so AWS instance type, then the server1 dot server1, then dot public IP. These are the basic parameters required for making the connection. Connection type is defined. Now the provisioners type. What are we going to achieve? Are we going to copy the file or are we going to run the commands? We'll use both. Okay. I'm going to copy my index file. I'm going to install Apache web server, for which I would need to update my repository. I need to install the package. I need to start the service. Okay. Assume that it is a web development project. So I will use provisioner type file, then here source. Since we are copying, we would need source and destination. So source within double quote my web directory. For example, if I have my web directory something like this, then I can use the directory. I'm going to only use index.html that need to be copied from my local system to target system. Here I have not created my index.html. I will create it later. And what about the destination? Within double quote, you can define any other directory, but I will go with the default. Okay, so this provisioner will make sure that to copy the index.html to the target location. What next? Then we are going to use a remote execute provisioner to run some set of commands. So inline, okay, here you can put all commands like a shell script. Okay, first I will run apt-get update. Then I will run apt-get -y install Apache 2. Then I will start the service. So this is how, based on your task, we need to apply this logic to use provisioner file type and provisioner remote execute. Just end of these each commands, just put comma. We'll apply this configuration. In case of any issues, we'll troubleshoot it. Before that, I need to create a index.html. Okay, this is my simple index.html. So let me apply this configuration. Meantime, we can go to our EC2 page and refresh it. So server 1 resource is created with t2.micro, but still our provisioning is going on. Meantime, we will try to connect to this EC2 server using putty. Okay, the username is Ubuntu because I use Ubuntu server, not Amazon Linux. So accordingly, I need to update my connection type. So the username should be Ubuntu. So let me cancel this, again apply it. So once I have changed this connection type and applied the configuration, if you see the existing EC2 instance is getting destroyed. I will tell you why later of this session. Okay, here if you see we got an error like where www.html is not exist. So that is why it is not unable to copy the file. Okay, so what I will do, I will copy this remote execute provisioner before the file type. So it will install Apache 2 and also it will create the default directories. Let me reapply again. Now again if you see, this EC2 is destroying because it is not a soft parameter. For example, if I change these tags, if I do apply, the EC2 will not destroy, it will refresh it. But these connection types provisioners are kind of a hard resources. So it has to be destroy and recreate the resources. So if you don't want to go for configuration management and if you want to rely with your Terraform, then you can go for this kind of provisioners. If not, I would suggest to go with configuration management too. So we have got a permission denied. Let me check it manually. Refresh the page. Okay, if you see this, the index.html file is created by root user. That is why the Ubuntu user is unable to copy the file into the destination. Okay. So we should have a knowledge on this kind of server setup as well. What kind of command we have to run, what will be the impact, all these things you must be aware of it. Okay. So what I can do here is, see, we cannot use sudo or we cannot take the admin privilege while using this file provisioner. Okay. So we need to apply a different logic how we can copy this index files. So file we cannot copy now. What we can do is we can copy this index.html to our home directory. Okay, now what I will do, I will copy this provisioner next to this file. After installation, I can use sudo copy -rf /var/www html index.html. Let's apply this again. Okay, the configuration is applied. Let me go back to EC2, refresh the page. Okay, so we got one EC2 instance and this is the IP. Try to access this in the browser. Okay, so our index.html is copied to the target instance. That is why I am able to see the response of the index.html. So basically Terraform provisioners will help us to perform some kind of post setup task. It has multiple types: file, local execute, remote execute. Local execute will be performed only within your local system, not on the target infrastructure. For performing anything on the target infrastructure, then we need to go for file type or remote execute. File type is helpful only when you want to copy a file or directory to the target infrastructure, then use the file provisioner. And if you want to run set of commands, then go for provisioner remote execute type. And if you see, when we do a small changes in these connection types or provisioners, the complete EC2 resource is destroyed and recreated. That is because Terraform is an infrastructure provisioning. So it is provisioning a resource and perform the task what you have mentioned in the provisioner. Perfect. But when you do a changes, how come the Terraform will know it? This is not an actual configuration management tool to perform on top of your server. Okay. This is a post setup script, which means once the resource is created newly, during the time itself, the post script should be executed. But here, once it is provisioned, you are modifying the changes. That is why it is deleting the resource and recreating it again. So this provisioner is only helpful for a lightweight configuration or setup when you need it. If you prefer to manage your state or services using configuration management tool, then go for it. So hope you have got an idea about Terraform provisioners and types and when to use them. See you in the next video. Till then, keep practicing and have fun.
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.learneticguide.net.